Have you ever looked up at the night sky and felt a quiet sense of wonder at its sheer, unending size? How far does it all go? Does it have an edge? And what is our place within it all? Tonight, we will wander through these questions together, not as a challenge for the mind, but as a gentle story to soothe it. There is no need to grasp every detail, only to float along on the current of the journey. So, before we begin, allow yourself to settle in. Let the weight of your body feel supported. Notice the soft rhythm of your breath, and give yourself permission to let the day fall away. Before we drift off into the cosmos, I wonder where you are listening from tonight. If you feel inclined, you might share your city or town and the time of night in the comments below, a small signal from one quiet part of the world to another. Our journey begins not in the cold, distant reaches of space, but right here, in the soft and familiar quiet of our world. It begins with the gentle pull of gravity that holds us, the whisper of the air we breathe, and the comforting knowledge that we are home. This is our starting point, a place of peace from which we will begin our gentle exploration of everything beyond. Let your awareness settle upon the Earth. Feel it not as a planet spinning in space, but as the ground beneath you, solid and steady. Imagine the feeling of soft grass or warm sand, the gentle presence of the air on your skin. This world is a place of incredible comfort, a sanctuary of life in the vast quiet of the cosmos. For all of human history, this has been our entire universe, a boundless expanse of oceans, continents, and sky. From this perspective, the world is immense, its horizons endless, its depths profound. Think of the deepest oceans, canyons of silent water where sunlight has never reached. A world of pressure and cold that is as alien to us as the surface of a distant moon. Think of the highest mountains, their peaks scraping the upper atmosphere, their stony shoulders covered in ancient ice. All of this vastness, all of this variety, is held together on a single beautiful sphere. Now, let us gently begin to drift upward, rising so slowly that the motion is barely perceptible. We rise above the trees, above the clouds, and we look down upon the gentle curve of our world. From here, we can see the continents taking their familiar shapes, the oceans shimmering in a deep, peaceful blue. And as we continue to ascend, we notice something remarkable: the thin, delicate layer that surrounds it all. This is our atmosphere, a fragile veil of gas that holds in all the warmth, all the air, all the life that we have ever known. It is a soft, blue halo that separates the familiar world from the immense emptiness that lies beyond. From the ground, the sky looks infinite, but from up here, we can see it for what it is: a finite, precious resource, a beautiful, blue bubble of safety. This atmosphere is our embrace, the final, gentle hug of our planet before we venture out into the great quiet. It is what makes our world a pale blue dot in the cosmic ocean. Down below, millions of stories are unfolding. Lives are being lived. Dreams are being dreamed, all contained within this tender layer. The storms that seem so powerful on the surface appear from here as silent, swirling patterns of white cloud. The vast deserts look like strokes of golden paint on a blue canvas. There is a profound peace in this perspective, a sense of seeing the whole picture at once. The world breathes below us, a single living entity. The journey we are about to take will lead us to scales of size and distance that are difficult for the mind to hold. But it is important to remember this starting point. This beautiful, fragile, and irreplaceable home is the anchor of our journey, the reference point to which all other scales will be compared. Let the image of this perfect blue marble, cradled in the blackness of space, fill your mind. It is a place of warmth and life, a tiny island of complexity in a universe of serene simplicity. This is where we come from. This is our quiet starting point. Now, as we float in the peaceful space just beyond Earth's atmospheric embrace, our gaze is naturally drawn to our closest and most constant celestial companion, the moon. For all of human history, it has been a silent witness in our night sky, a source of gentle light, myth, and wonder. From Earth, it seems so close, as though we could almost reach out and touch its pale, pockmarked face. But from our new vantage point, we can begin to appreciate the true distance that separates us. Let us begin to drift towards it, not in a fast machine, but at the gentle pace of thought. The Earth slowly shrinks behind us, its vibrant blue and white giving way to the deep velvet blackness of space. The journey to the moon is our first true step into the cosmos, and it provides our first lesson in cosmic scale. The distance is approximately 238,000 miles, a number so large it can feel abstract. Let us try to feel it differently. Imagine you could drive a car at a steady highway speed, without ever stopping. It would take you about 6 months to cover that distance. Or think of all the human beings who have ever lived. If they could all hold hands, they might just form a chain that could stretch from the Earth to the moon. This is not a small gap. It is a significant chasm of quiet space. As we drift across it, we are truly in a new realm. The sun's light is unfiltered here, sharp and brilliant, while the shadows are deeper and darker than any we know on Earth. There is no air, no sound, only a profound and penetrating silence. As we draw closer, the moon grows in our field of view. It is no longer a flat silver disk, but a three-dimensional world of its own. We can see its surface in exquisite detail. Vast, dark plains of ancient solidified lava, which early astronomers mistook for seas and named them Maria. We see countless craters, scars from billions of years of impacts from asteroids and comets. Some are small and simple bowls, while others are vast, complex basins with central mountain peaks. Each crater tells a story of a violent event in the distant past, now frozen in a state of perfect stillness. There is no wind here, no water to erode these features. The footprints left by the Apollo astronauts in the 1960s and 70s will remain there, perfectly preserved, for millions of years. The moon is a museum of the solar system's history, a silent testament to the passage of eons. It has no atmosphere to scatter the sunlight, so the sky above it is always a perfect, unending black, even with the sun shining. From its surface, the Earth would hang in that black sky like a beautiful blue and white celestial jewel, a constant reminder of the home we have left behind. This first step of our journey, this peaceful traverse to our lunar companion, has recalibrated our sense of distance and shown us that even our closest neighbor is a world away. Having now arrived in the quiet vicinity of the moon, let us pause and simply float, turning our attention away from the solid worlds of Earth and Moon, and toward the space that fills the gap between them. We often think of space as empty, a word that can feel cold or lonely. But tonight, let us reframe that idea. Let us think of this emptiness not as a void, but as an ocean, a vast, serene, and deeply peaceful ocean of quiet. On Earth, even in the quietest moments, there is always some sound, some subtle vibration in the air. Here, there is a silence that is absolute. It is a silence that allows the mind to rest, to expand, to simply be. This cosmic ocean is not truly empty. It is filled with the constant, invisible light of the sun, a stream of particles called the solar wind that flows outward in all directions. It is crisscrossed by the gentle, unseen force of gravity, the threads that tie the moon to the Earth and the Earth to the sun. And occasionally, a tiny fleck of dust, a micrometeorite, will drift silently by, a lonely traveler on an ancient journey. But for the most part, this realm is defined by its sheer, peaceful spaciousness. It is a place of pure distance. The 238,000 miles that separate Earth and Moon are the first measure of this ocean's breadth, a single, comprehensible drop in a much larger sea. Thinking of space in this way helps us prepare for the even greater scales we are about to encounter. The journey from our world to its moon is just a short trip across a calm coastal bay. Soon, we will set sail for the distant shores of other planets, and the distances will grow from thousands of miles to millions, and then to hundreds of millions. If we think of this space as a cold, hard vacuum, the journey can feel daunting. But if we imagine it as a calm, quiet ocean, it becomes a peaceful meditation. We are not hurtling through a void. We are drifting on a gentle, cosmic current. This ocean of emptiness is the medium through which all celestial bodies travel. It is the canvas upon which the universe is painted. It does not separate the worlds so much as it connects them, giving them the room they need to follow their silent, graceful, orbital paths. Let your mind relax into this concept of serene, spacious quiet. It is the fundamental nature of the universe we are exploring, and finding peace within it is the key to understanding its mind-boggling scale without feeling overwhelmed. Now, cradled in the profound quiet of the cosmic ocean, we gently turn our attention inward, toward the heart of our solar system. From our peaceful vantage point near the Earth and Moon, we can begin our gentle tour of the inner worlds, our closest planetary neighbors. These are the rocky terrestrial planets, each one a unique story of cosmic formation, and each one a lesson in how special our own world truly is. Let us first drift toward the Sun, to the innermost planet Mercury. This small, dense world is a place of extreme contrasts. Because it has almost no atmosphere to trap heat, its sun-facing side is scorched by temperatures hot enough to melt lead, while its night side plunges into a deep, crystalline cold far below freezing. Its surface is a testament to a violent past, covered in craters like our Moon, and also marked by strange cliffs and scarps that formed as the planet's iron core cooled and shrank, causing its crust to wrinkle like the skin of a drying apple. It is a silent, airless world, locked in a slow dance with the Sun's immense gravitational pull. Gently pulling back from Mercury's stark landscape, we drift outward to the next planet, Venus. Shrouded in a thick, beautiful veil of pale yellow clouds, Venus was once thought to be Earth's twin, a potentially lush and tropical paradise. But as our understanding grew, we discovered a very different reality. Its atmosphere is incredibly dense, nearly 100 times thicker than Earth's, and is made almost entirely of carbon dioxide. This has created a runaway greenhouse effect, trapping heat so effectively that its surface is even hotter than Mercury's, making it the hottest planet in our solar system. The atmospheric pressure on its surface is crushing, equivalent to being nearly a kilometer deep in one of Earth's oceans. It is a world of immense heat and pressure, a cautionary tale of an environment pushed to an extreme, its surface forever hidden beneath a beautiful but toxic cloak of sulfuric acid clouds. We now retreat from the intense heat of Venus, drifting back past the familiar orbit of Earth, and journey outward to the fourth and final inner world, Mars. The red planet has captivated human imagination for centuries, a world of rusty, ochre-colored dust that hints at a very different past. Today, Mars is a cold, desert world with a very thin atmosphere, but the evidence of a warmer, wetter history is etched all over its surface. We see vast, dry riverbeds, ancient deltas where water once flowed into great crater lakes, and polar ice caps made of both water and frozen carbon dioxide. It is a world that may have once been much more like Earth, but which lost its protective atmosphere and its liquid water to the coldness of space over billions of years. It holds the quiet promise of ancient secrets, perhaps even the fossilized memory of simple life from a time when its skies were bluer and its rivers flowed freely. Seeing these three worlds, scorched Mercury, suffocating Venus, and frozen Mars, each with its own unique and harsh environment, deepens our appreciation for the gentle, life-sustaining balance of our own blue marble, floating peacefully in the space between them. Our gentle journey outward from the Sun has taken us past the four rocky inner worlds. Now, before we venture into the realm of the giants that lie beyond, we must pass through a unique and serene region of our solar system, the asteroid belt. Popular imagination often pictures the asteroid belt as a chaotic, densely packed field of tumbling boulders, a dangerous cosmic traffic jam that is difficult to navigate. The reality, however, is far more peaceful and far more vast. Let us imagine this region not as a field, but as a vast and silent river of stones slowly circling the Sun. The asteroids themselves, the leftover building blocks of planets that never formed, are incredibly far apart from one another. If you were to stand on one, you would likely not be able to see another with the naked eye. The average distance between them is hundreds of thousands of miles, far greater than the distance between the Earth and the Moon. So, this is not a place of collision and chaos, but one of immense, quiet solitude. Each asteroid is on its own long, lonely and predictable path, a silent dance choreographed by the sun's gravity. Some are small, like pebbles, while others are hundreds of miles across, large enough to be considered minor planets. They are ancient, irregular worlds of rock and metal, unchanged for billions of years, holding the secrets of the solar system's birth. Crossing this belt is not a perilous act, but a serene transition. It is a peaceful, shimmering boundary that marks the end of the warm, rocky inner solar system and the beginning of the cold, the vast domain of the gas giants. Let us drift through this river of silence, feeling the gentle pull of what lies ahead. Having crossed the serene and spacious river of the asteroid belt, we feel a profound shift in the scale of our surroundings. We are now entering the realm of the outer solar system, the domain of the gentle giants. The first of these magnificent worlds to greet us is Jupiter. From a distance, it appears as a majestic, striped beacon. But as we draw closer, its true immensity reveals itself. Jupiter is a world unlike any we have yet encountered. It is a planet made not of rock, but almost entirely of gas, primarily hydrogen and helium, the same simple ingredients that make up the Sun. Its sheer size is difficult to comprehend. If you were to gather all the other planets, moons, asteroids, and comets in our solar system, they would all fit comfortably inside Jupiter, with room to spare. Its surface is not solid, but a deep, churning atmosphere with bands of clouds in beautiful shades of cream, orange, and brown. These bands are vast jet streams, flowing in opposite directions at hundreds of miles per hour. Within these bands are swirling storms, some larger than our entire planet. The most famous of these is the Great Red Spot, an ancient, persistent hurricane that has been raging for centuries. Yet, from our peaceful vantage point, we do not perceive this as violent. Instead, it is a grand and silent meteorological ballet, a slow-motion painting of atmospheric dynamics on a planetary canvas. Jupiter's immense gravity makes it the great anchor of the outer solar system. In a way, it acts as a cosmic guardian, its powerful gravitational field often deflecting or capturing stray comets and asteroids that might otherwise venture into the inner solar system, protecting worlds like ours. And Jupiter is not alone. It is the center of its own miniature solar system, with a family of nearly 100 moons. 4 of them, the Galilean moons, are worlds in their own right. Volcanic Io, icy Europa with its hidden ocean, massive Ganymede, and cratered Callisto. Drifting onward from Jupiter, we travel a distance so great that the entire journey from the Sun to the asteroid belt could be repeated. The space out here is even quieter, the Sun's light more distant and soft. And then, we see it, a sight that has inspired awe and wonder for as long as we have turned telescopes to the sky, the planet Saturn. While smaller than Jupiter, Saturn is still a colossal gas giant, but its identity is defined by its breathtaking system of rings. From afar, they look solid, like a beautiful flat halo placed around the planet. But as we draw closer, we see that they are an illusion of solidity. The rings are, in fact, composed of billions upon billions of individual particles of water ice, ranging in size from tiny specks of dust to chunks as large as a house. They are spread out in an incredibly thin, shimmering sheet, so thin in proportion to their width that they are like a sheet of paper the size of a city. These countless particles each follow their own perfect orbit, a silent, graceful dance around the planet. They catch the distant sunlight, making Saturn one of the most beautiful and serene objects in our entire cosmic neighborhood. These 2 giants, Jupiter and Saturn, with their immense size and quiet majesty, govern the outer solar system. They show us a new scale of existence and prepare us for the even more unimaginable distances that separate our entire solar system from the stars beyond. Having journeyed through the family of planets, from the scorched inner worlds to the majestic outer giants, our exploration now turns its focus inward. We drift back toward the very center of it all, to the one body that holds this entire system together in its warm, gravitational embrace. We now arrive at the heart of our home, our star, the Sun. Let us now travel to the very center of our solar system, to the source of all its light, warmth, and life. From a safe, imaginary distance, we behold the Sun. It is not the fierce, angry ball of fire we sometimes imagine, but a perfect, serene sphere of brilliant golden white light, hanging in the absolute silence of space. Its surface is a calm ocean of roiling plasma, with graceful arcs of energy and dark, cool sunspots that appear and fade like temporary islands. The sheer scale of our star is the first thing that stills the mind. If the Earth were the size of a small pebble, the Sun would be a giant glowing doorway. You could fit more than 1 million Earths inside of it. In fact, our Sun accounts for 99.8% of all the mass in the entire solar system. Everything else, every planet, moon, asteroid, and comet we have visited on our journey so far is merely the leftover dust and gas from its formation. All the worlds we have seen are just tiny companions, held in a gentle, unwavering orbit by the Sun's immense presence. But what makes the Sun shine? It is not a fire in the way we understand it. It does not burn fuel by combining it with oxygen. Instead, its energy comes from a process at its very core, a process of profound and quiet transformation known as nuclear fusion. Deep within the Sun's center, the pressure from its own unimaginable weight is so intense, and the temperature is so high, over 27 million degrees Fahrenheit, that the very nature of matter begins to change. Here, individual hydrogen atoms, the simplest and most abundant element in the universe, are gently pressed together. They overcome their natural repulsion and merge, or fuse, to become a new element, helium. This act of transformation, of creating something new from something simpler, releases a tiny, almost imperceptible whisper of energy in the form of a particle of light, a photon. This process is not an explosion. It is a slow, steady, and deeply reliable hum, like the heartbeat of the solar system. Every second, the Sun converts about 600 million tons of hydrogen into helium. The energy released by this process is immense, but it begins its life trapped deep within the dense core of the star. A single photon created in the core does not travel straight out. Instead, it begins a long, meandering journey, being absorbed and re-emitted by countless atoms in a journey that can take, on average, over 100,000 years. The light that warms your face on a sunny day may have begun its existence in the heart of the Sun before modern humans even walked the Earth. It is ancient energy. After this long, slow journey to the surface, the photon is finally free. It then takes only 8 minutes to travel the 93 million miles of empty space to reach our planet. This ancient light is the foundation of our existence. It drives our weather, it warms our oceans, and through the magic of photosynthesis, it provides the energy for nearly all life on our world. The food we eat is, in a very real sense, a form of stored sunlight. The Sun is also our gravitational anchor. Its immense mass doesn't just pull on the planets. It bends the very fabric of space-time around it, creating a gentle cosmic valley. The planets are not trapped in their orbits. They are simply following the most natural and effortless path, like a marble rolling along a smooth, curved surface. This constant, gentle guidance is what keeps our entire system in a state of beautiful, predictable harmony. This is our star, a serene and life-giving presence, the heart that defines our entire solar system. By understanding its calm and steady nature, we are prepared to understand the billions of other stars that await us on the next part of our journey. For a long time, we have thought of our solar system as a collection of planets orbiting the Sun. But the Sun's influence extends far, far beyond the orbit of the most distant planet. Our star is not just a source of light and gravity. It also constantly exhales a gentle, continuous stream of charged particles into space. This stream is known as the solar wind, and it flows outward in every direction, traveling at hundreds of miles per second. This solar wind creates a vast protective bubble around our entire solar system, a bubble known as the heliosphere. Let us imagine this bubble. It is not made of any substance we could see or touch, but it is a distinct region of space, a magnetic cocoon carved out by our Sun. Inside this bubble, we are in the Sun's domain. The space here is filled with the particles and magnetic fields that come from our star. Outside this bubble lies a completely different realm, the vast, deep ocean of interstellar space. This heliosphere is immense, extending billions of miles past the orbit of Pluto. The Voyager 1 and Voyager 2 spacecraft, launched in 1977, have been traveling for decades, and only in the last several years have they finally crossed the boundary of this bubble and entered interstellar space for the first time. The edge of the heliosphere, where the sun's gentle solar wind is finally slowed down and pushed back by the collective wind of other stars in our galaxy, is called the heliopause. Think of it as a cosmic shoreline, where the river of our sun's influence flows into the great, quiet ocean of the galaxy. This boundary is not a hard wall, but a soft, fluctuating frontier. It is the true edge of our solar system, the final, shimmering layer of our sun's embrace. The heliosphere acts as a shield for the solar system. Interstellar space is filled with high-energy particles called cosmic rays, which are born from distant, powerful events like supernova explosions. The heliosphere's magnetic field deflects a significant portion of these cosmic rays, protecting the planets within from this more intense radiation. In this way, our sun creates a pocket of relative calm, a sheltered harbor in the cosmic sea. Our entire journey so far, from Mercury to the gas giants, has taken place deep within this protective bubble. Now, as we prepare to leave our home system, we must first travel to the very edge of this solar wind-inflated cocoon. As we drift outward for billions of miles, the planets fade into tiny, insignificant points of light, and eventually, even the sun itself becomes just the brightest star in the sky. We are journeying to the edge of the sun's breath, to the point where its whisper finally fades into the silence of the galaxy. Passing through the heliopause is the true act of leaving home. It is a peaceful, silent crossing from one realm into another, from the familiar space dominated by our star to the mysterious and profoundly vast space that lies between the stars. Even after we have crossed the heliopause, leaving the sun's magnetic bubble behind, we have not quite escaped its gravitational influence. The sun's light may be faint out here, its solar wind gone, but its gravity, the most patient and far-reaching of all forces, still holds sway. We are now entering the most distant, vast and mysterious region of our solar system, the Oort cloud. This is not a cloud in the way we think of clouds in our sky. It is a theoretical, immense, and perfectly spherical shell of icy bodies that is believed to encircle our entire solar system. It is a place of profound cold and darkness, a vast celestial sphere whose existence we infer from the long-period comets that occasionally fall into the inner solar system. These comets, with orbits that take thousands of years, are thought to be ancient, icy travelers that have been nudged from their distant home in the Oort cloud by some subtle gravitational disturbance. The scale of the Oort cloud is almost impossible to picture. Its inner edge might begin several hundred times farther from the Sun than Pluto, but its outer edge may extend a full light-year, or even further, into space. To put that into perspective, the outer edge of the Oort cloud may reach nearly a quarter of the way to our nearest stellar neighbor, Proxima Centauri. Our entire solar system, from the Sun out to the heliopause, would be like a tiny seed in the center of a vast spherical orchard. The objects within this cloud, perhaps trillions of them, are incredibly far apart from one another. If you were floating next to one of these icy comet nuclei, you would likely be millions of miles away from its nearest neighbor. The darkness here is absolute, broken only by the faint, distant light of the stars. These icy bodies are pristine relics from the formation of our solar system over 4.5 billion years ago. They are the frozen, leftover building blocks that were flung outward by the gravity of the young gas giants. They have been preserved in a deep cosmic freeze ever since, holding the original chemical recipe of the nebula from which our sun and planets were born. This is the sun's final, most tenuous possession. The objects here are so loosely bound by the sun's gravity that they can be easily disturbed by the gravitational pull of passing stars or the tides of the galaxy itself. The Oort cloud represents the true final boundary of the sun's gravitational kingdom. It is a silent, icy whisper of the sun's presence, a ghostly sphere that marks the final transition from our solar system to the true interstellar void. Drifting through this immense, sparse and silent sphere of ice is our final act of departure. Here we are, floating in the profound stillness of the Oort cloud, at the very edge of the sun's gravitational kingdom. Let us pause our journey for a moment and turn around, to look back at the home we have left behind. From this incredible distance, a light year away from its center, our entire solar system is invisible to the naked eye. The giant planets, the asteroid belt, even the Earth itself, are all completely lost in the glare of a single point of light. And that point of light is our sun. From here, it is no longer a disk, no longer a tangible source of warmth. It is simply a star, albeit the brightest one in our sky. It looks just like the other stars that surround us. A beautiful, brilliant, but distant diamond on the black velvet of space. All of our journey thus far is contained within that single, serene point of light. The pale blue embrace of Earth's atmosphere, the silent, cratered face of the moon, the scorched plains of Mercury, and the shrouded hellscape of Venus. The red deserts of Mars, the majestic, swirling clouds of Jupiter, and the ethereal, shimmering rings of Saturn, all of it. Every world, every story, every wonder has collapsed into a single stellar point. The hundreds of millions of miles we have traveled have been reduced to an infinitesimally small space held within the light of that one star. This perspective is not meant to make us feel small, but to give us a sense of profound peace and connection. Everything we have ever known, every person who has ever lived, every mountain and every ocean, is contained in the gentle glow of that distant, familiar star. This is our final goodbye to our solar system as a cohesive place. We are now about to enter a new realm, one where the fundamental unit of measurement is no longer the mile or the kilometer, but the distance between the stars themselves. We are leaving the harbor and setting out onto the open ocean. The light of our sun will now become our lighthouse, a beacon that marks the direction of home as we journey forward into the great quiet. Let this image be etched in your mind. A single, familiar star, holding within its light an entire family of worlds. It is a peaceful and humbling image, one that provides a sense of closure on this first great leg of our cosmic exploration. We have now seen the full extent of our home, from its warm heart to its coldest, most distant edge. With a final, gentle glance back, we now turn our attention forward to the interstellar shore that awaits. Having taken our final look back at the distant light of our sun, we now turn our full attention forward and drift completely free of its gravitational embrace. We have crossed the final, invisible boundary. We are now adrift on the interstellar shore, the vast and quiet ocean of space that lies between the stars. The quality of the silence here is different, deeper. Within the solar system, there was always the sense of being within a system, a family of objects orbiting a central point. Here, that feeling is gone. We are now in the great in-between. The nearest stars are no longer just points of light in a distant sky. They are now destinations, other shores impossibly far away. The light that reaches us here is a soft, collective glow from billions of distant suns, a gentle, ambient starlight that fills the void. The space here is more empty than any we have yet encountered. While the Oort cloud was sparse, it was still populated with trillions of icy bodies. Here, in interstellar space, the average density is just a few atoms per cubic centimeter. It is a state of emptiness that is almost perfect, a canvas of pure, unadulterated space. Drifting here is like floating in the deepest, calmest ocean imaginable, far from any land, where the water is perfectly still, and the surface reflects the stars with perfect clarity. The journey we are about to undertake, to our nearest stellar neighbor, is of a completely different order of magnitude than anything we have done before. The 93 million miles from the Earth to the Sun is a distance we have now learned to comprehend. But the distance to the next star is nearly 300,000 times greater than that. Our old ways of thinking about distance, in miles and kilometers, begin to lose their meaning here. They become like trying to measure the distance between continents in inches. The numbers are simply too large, too unwieldy for the mind to hold. We are on the shore of a new kind of distance, and to navigate it, we will need a new kind of measurement, a new way to understand the vastness that unfolds before us. The darkness here is not frightening, it is serene. It is a peaceful, patient darkness that holds the potential for countless other worlds, other suns, other solar systems just like our own. We are no longer travelers within a single star's domain. We are now true interstellar voyagers. Before we begin the long drift to the next point of light, let us simply rest here for a moment, on this quiet shore, and let the sheer scale and peace of the interstellar ocean wash over us. This is the true nature of our galaxy, this immense quiet space between the islands of light. As we float peacefully on the interstellar shore, the stars around us seem to hang like distant, silent lanterns. To journey between them, to understand the true size of our galactic neighborhood, our old measurements will no longer suffice. We must now adopt a new scale, one born not of human travel, but of the fastest thing in the universe, a beam of light. To truly appreciate the next stage of our journey, we need a new way to measure our progress. The miles and kilometers that served us so well within our solar system have become impossibly cumbersome. To speak of the distance to the nearest star in miles would be to use a number in the trillions, a figure so large that it loses all intuitive meaning. We need a larger, more graceful unit of measure, and the universe provides one for us. The speed of light. Light is the fastest thing that exists. In the vacuum of space, a particle of light, a photon, travels at a speed of approximately 186,000 miles every single second. This speed is absolute, the ultimate speed limit of the cosmos. Nothing with mass can ever reach it. Let us try to feel this incredible speed. In a single second, a beam of light could circle the Earth more than 7 times. In the time it takes to draw a slow, deep breath, light has already traveled from the moon to the Earth and back, several times over. It is a speed that is almost instantaneous on a human scale. So, instead of measuring cosmic distances with static units like miles, we can begin to measure them in terms of time, using this one constant speed. We can ask, how long would it take for a beam of light to travel from one point to another? We have already encountered this concept. We know that the light from our sun takes about 8 minutes to reach the Earth. So, we can say that the Earth is 8 light minutes away from the sun. The light from the sun takes several hours to reach Pluto. So, we can say the solar system is a few light hours across. This new way of measuring feels more natural, more connected to the fabric of the universe itself. Now, let us extend this idea to its full cosmic potential. Let us consider how far a beam of light could travel if it journeyed for an entire year. This distance is what we call a light year. It is not a measure of time, but a measure of distance. The distance light covers in 1 year. And that distance is immense. It is nearly 6 trillion miles. This is our new cosmic mile, our new unit of measure for the interstellar ocean, a light year. The number itself, 6 trillion miles, is still too large to truly grasp, so let us instead focus on the concept, the patient, year-long journey of a sunbeam across the empty dark. Imagine a single photon leaving a distant star. It travels for a full year, across an uninterrupted chasm of quiet space, before it finally reaches its destination. That entire journey is a single light year. By adopting this new measure, we are no longer fighting against the immense numbers of the cosmos. We are flowing with them, using the universe's own fundamental constant as our guide. It is a more peaceful, more intuitive way to understand the true, mind-boggling size of the space that separates the stars. With this new tool in our minds, the light year, we are now ready to embark on the next leg of our journey, the voyage to our nearest stellar neighbor. With our new understanding of the light year as our guide, we turn our attention from our own sun to the next nearest star. In the sky, as seen from Earth, it is part of the Alpha Centauri system. But our closest stellar companion is a small, faint red dwarf star called Proxima Centauri. It is so dim that despite its proximity, it is invisible to the naked eye. This humble star is our closest neighbor in the vast city of the galaxy, and the distance to it is just over 4.2 light years. Let us now begin the slow, patient journey across this gap. We are not traveling at the speed of light, of course, but at the gentle, meditative pace of our imagination. Even so, let us consider what this distance truly means. It means that the light from this star, the faint reddish glow that we would see, took more than 4 years to cross the void and reach us. When we look at Proxima Centauri, We are seeing it not as it is today, but as it was over 4 years ago. We are looking into the past. This journey of 4 light years is the single greatest leap in scale we have yet taken. Let us try to feel its immensity. If our sun were a grapefruit in New York City, the Earth would be a grain of sand orbiting it from about 30 feet away. On this scale, Proxima Centauri, the nearest neighboring grapefruit, would be in San Francisco. The space in between would be almost entirely empty. Our fastest spacecraft, like the Voyager probes, would take tens of thousands of years to cover this distance. But in our quiet exploration, we can drift across this chasm peacefully. As we travel, our own sun slowly shrinks, eventually becoming indistinguishable from any other star. Its special status as our home star lost to the sheer distance. The familiar constellations of our night sky would begin to warp and distort as we are changing our perspective on the three-dimensional arrangement of the stars. After a long, serene drift, we arrive in the vicinity of Proxima Centauri. It is a very different kind of star from our sun. It is a red dwarf, much smaller, cooler, and dimmer. Its light is a soft, gentle crimson glow compared to the bright, golden-white light of our own star. Because it burns its fuel so slowly and efficiently, it will live for trillions of years, far, far longer than our sun. It is a star of great patience and longevity. We know that at least one planet orbits this star, a rocky world slightly more massive than Earth, called Proxima Centauri b. It orbits very close to its faint star, in its habitable zone, the region where temperatures could potentially allow for liquid water. We know nothing of what this world is like, whether it is a barren rock or a world with an atmosphere and oceans, but its mere existence is a profound revelation. It tells us that our solar system is not unique. The very next star over has a planetary companion, suggesting that planets may be incredibly common throughout the galaxy. Our first interstellar voyage has not brought us to a place of emptiness, but to another star system, another potential family of worlds. Having arrived at our nearest neighbor, the quiet red dwarf Proxima Centauri, let us now gently expand our awareness. We can now see that our sun is not an isolated star, but part of a local community. From our new vantage point, we can look around and see the other stars that make up our immediate cosmic neighborhood. Within a radius of about 10 light years from our sun, there are about a dozen other star systems. This is our local stellar group, a small, gravitationally unbound cluster of suns drifting through the same general region of the galaxy. Let us take a moment to meet a few of these silent neighbors. There is, of course, the Alpha Centauri system itself, of which Proxima Centauri is a distant companion. The two main stars, Alpha Centauri A and B, are much more like our sun, and they orbit each other in a graceful binary dance. A little further out, at about 6 light years from us, is Barnard's star, another old, calm red dwarf, famous for moving across our sky faster than any other star. At around 8 light years, we find the star Wolf 359, another very faint red dwarf. In fact, most of the stars in our immediate vicinity are these small, dim, and incredibly long-lived red dwarfs. Our sun, a medium-sized yellow star, is actually somewhat uncommon in this local census. The stellar neighborhood is a place of quiet, long-burning embers. As we float in the center of this imaginary 10-light-year bubble, we can see these neighboring stars scattered around us in all directions. Our sun is in one direction, Alpha Centauri in another, Sirius, the brightest star in Earth's night sky, about 8.6 light-years away, shines brilliantly in another. We are now seeing the stars not as a flat, painted backdrop, but as they truly are, a three-dimensional distribution of points of light, each one separated from the others by trillions of miles of silent, empty space. This small cluster of stars is our local family. We are all moving together like a loose flock of birds through the vast expanse of the Milky Way galaxy. Seeing our sun as just one member of this small group gives us a new sense of perspective. For all of human history, our star was the only one that mattered, the only one we could feel, but now we see it as just one of the locals, a single house in a very small and very spread-out celestial suburb. This understanding is a crucial step in comprehending the true size of our galaxy. Before, we thought of the space between stars as the primary feature of the cosmos. Now, we are beginning to see that the stars themselves form a structure, a community. This gentle zoom out, from a single star system to a neighborhood of a dozen, is preparing us for the next leap of imagination, to a structure that contains not a dozen but hundreds of billions of stars. As we rest here, in the quiet, spacious center of our small stellar neighborhood, let us reflect on a profound implication of what we have learned. We journeyed from our sun to Proxima Centauri, and we found a planet. We know that our sun has a family of 8 planets, plus countless dwarf planets and other smaller bodies. The other stars in our local group, like Alpha Centauri A and B, and Tau Ceti just under 12 light-years away, are also known to have planets orbiting them. The quiet revolution in astronomy over the last few decades has been the discovery that planets are not the exception but the rule. It seems that the process of star formation naturally and commonly leads to the formation of planets around those stars. The same disk of gas and dust that gives birth to a star also provides the raw material for a family of worlds. So now, as we look around at the dozen or so stars in our immediate vicinity, we must change our perception. We are not just looking at points of light. We are looking at points of potential. Each one of those stars is very likely a solar system unto itself. The bright, sun-like star Alpha Centauri A probably has its own entourage of worlds. The dim, ancient Barnard's star likely has its own family of cold, rocky planets. Every single star we see is the potential heart of a system, the gravitational anchor for its own unique collection of planets. This realization fills the vast emptiness of interstellar space with a quiet, shimmering possibility. The void is not so empty after all. It is punctuated by these countless little islands of matter, these stellar systems. Let your mind drift with this idea. Imagine the variety. Some systems might have giant gas planets orbiting very close to their star. Others might have multiple rocky worlds in the habitable zone. Some might be ancient systems around calm red dwarfs, where life could have had trillions of years to evolve. Others might be young, dynamic systems still chaotic with planetary formation. The 12 stars in our neighborhood could represent a dozen different cosmic laboratories, each running its own unique experiment in planetary science. And if this is true for our tiny, local patch of space, what does it mean for the galaxy as a whole? The quiet understanding that dawns upon us is that the sky is full, not just of stars, but of solar systems, billions upon billions of them. The number of planets in our galaxy almost certainly outnumbers the stars. This thought transforms the night sky from a collection of lonely, distant fires into a city of countless hidden worlds. Our journey has brought us to the understanding that we live in a universe that is incredibly fertile with the potential for worlds, a quiet testament to the creative power of gravity and time. Our perspective has grown from our planet, to our solar system, to our local neighborhood of stars. Now, let us take one more gentle step back. Let us see our small cluster of a dozen stars for what it is, a tiny, insignificant grouping within a much larger, more organized structure. All the stars in our immediate vicinity, including our sun, belong to a minor spiral arm of our home galaxy. This structure is known as the Orion Arm, or more accurately, the Orion Spur, as it is a smaller offshoot located between two much larger, more massive spiral arms. Imagine a vast celestial river of stars, tens of thousands of light-years long. Our solar system and all the neighboring stars we have just met are just a few drops of water in this immense, slowly flowing current. From our position inside this structure, it is impossible to see its full shape, but we can infer it by carefully mapping the positions of other stars and gas clouds. We are not in a dense, crowded part of the galaxy, nor are we in a desolate, empty region. We are in a relatively calm and spacious suburban lane of this cosmic city. This Orion Spur is a river of stars, gas, and dust. It contains many of the bright stars we see in our night sky, including those that form the constellation of Orion, which gives the spur its name. The beautiful Orion Nebula, a vast cloud of gas where new stars are being born right now, is also a prominent feature of our local spiral arm. So, our neighborhood is not just a random collection of stars, but part of a larger, coherent structure, a filament of stars and gas that is participating in the grand, slow rotation of the entire galaxy. Understanding our place in the Orion Spur gives us another crucial piece of the cosmic puzzle. We are beginning to see that our galaxy is not a uniform ball of stars, but a place with geography, with structure, with dense downtown cores and quiet, spacious suburbs like ours. It is an organized system on an unbelievable scale. Our sun is just one of hundreds of millions of stars in this single minor spiral arm. And this arm is just one of several that make up the beautiful spinning disk of our galaxy. We are connecting our small local cluster to the vast architecture of the Milky Way, and this provides the first real glimpse of the galactic structure that we will explore in our next chapter. Having understood our position within the Orion Spur, a minor arm of our galaxy, we can now understand a beautiful sight that has graced our night sky since the dawn of humanity, the Milky Way. When we are in a place far from city lights, on a clear, moonless night, we can see a faint, luminous band of light stretching across the entire arc of the sky. To ancient cultures, it was a celestial river, a path for spirits, or the spilled milk of a goddess. In reality, what we are seeing is the combined light of billions upon billions of distant, unresolved stars. And we see it as a band because we are looking at our own galaxy from the inside. Imagine being on a carousel. If you look up or down, you see a few scattered lights of the park around you. But if you look straight ahead, into the plane of the carousel itself, you see the dense, blurry streak of all the other lights and structures on the ride. Our galaxy is a vast, flat spinning disk, like a celestial carousel. Our solar system is embedded within that disk, in the Orion Spur, about 2/3 of the way out from the center. So, when we look out into space in any direction that is up or down out of the disk, we are looking through a relatively thin layer of stars. The sky in these directions is darker, and we see more of the empty space between the galaxies. But when our gaze is directed along the plane of the disk, we are looking into the heart of the galaxy, through the thickest, densest concentration of stars. That beautiful hazy band across the sky is our edge-on view of our own galactic disk. The light is densest and brightest when we look toward the galactic center, in the direction of the constellation Sagittarius. It is a river of stars, not a metaphorical one, but a literal one. We are seeing the light from the Orion Spur, and beyond it, the light from the next spiral arm inward, the Sagittarius arm, and beyond that, the light from the galactic core itself. All those individual stars, hundreds of billions of them, are too far away for our eyes to separate them, so their light blends together into a soft, shimmering, milky glow. This breathtaking sight, this river of stars, is the direct visual confirmation of our place within a grand, flattened, spiral structure. It connects the physical reality of our location in a spiral arm to the beautiful, awe-inspiring wonder we can witness with our own eyes. It is the perfect, seamless transition from understanding our local neighborhood to exploring the full, magnificent city of stars to which we belong. We now leave the scale of neighborhoods behind. Our journey takes us to a new level of awareness, as we pull our perspective back far enough to see our entire home, not as a collection of stars, but as a single magnificent entity. We are now going to explore our home galaxy, the Milky Way, a city of over 100 billion stars. Let us now perform the ultimate act of imagination. Let us drift up, far above the plane of the Orion Spur, traveling for tens of thousands of light years, until we can look down upon our entire home galaxy. From this godlike vantage point, the Milky Way reveals its true, breathtaking form. It is a vast, spinning spiral galaxy, a luminous disk of stars, gas and dust, 100,000 light-years across. This is our cosmic city, and its structure is one of serene and ordered beauty. At its heart is a dense, glowing, elongated bar of stars. From the ends of this central bar, several major spiral arms and a few minor spurs, like our own Orion Spur, curve gracefully outward, like the arms of a celestial pinwheel. These arms are not solid structures, but are what we call density waves, like a slow-motion traffic jam in cosmic material. As clouds of gas and dust move into these arms, they are compressed, triggering the birth of brilliant, new blue-white stars. This is why the spiral arms are so bright and well-defined. They are the stellar nurseries of our galaxy, the neighborhoods where creation is actively taking place. The entire disk rotates, but not like a solid object. The stars closer to the center complete their orbit much faster than the stars further out. Our Sun, located about 27,000 light-years from the center, takes about 230 million years to complete one single lap around the galaxy. This is sometimes called a cosmic year. The last time our solar system was in this position in its orbit, the first dinosaurs were just beginning to appear on Earth. The galaxy is a place of immense, slow and patient motion. The space between the spiral arms is less dense, containing older stars and less gas. Our Sun currently resides in one of these quieter regions, which is perhaps a fortunate place to be, away from the intense radiation and gravitational disruption of the more crowded, star-forming regions. The disk itself is remarkably thin. While it is 100,000 light-years in diameter, it is only about 1,000 light-years thick on average. This is an incredible proportion, thinner than a dinner plate. This entire structure, this beautiful, shimmering city of stars, is held together by the collective gravity of all the matter within it, both the visible stars and gas, and a much larger, unseen component we will soon explore. Gazing upon this sight, we can finally pinpoint our own tiny, insignificant place within it. We can see the major Sagittarius arm, and just outside it, the little Orion spur where our Sun and its family of planets reside. To see our home in this context, as a single star among hundreds of billions, all part of this vast, majestic, spinning structure, is to understand our place in the cosmos in a new and profound way. This is the Milky Way, our home, a floating, self-contained island universe, one of countless many in the cosmic ocean, but the only one we can truly call our own. Let this image of the grand spiral city settle into your mind, a place of quiet beauty and unimaginable scale. Our gentle exploration of our galactic city now takes us from our high vantage point, swooping down toward its very heart. As we move inward from our quiet suburban spur, the density of stars begins to increase dramatically. The sky here would be a breathtaking tapestry of light, with thousands of stars shining as brightly as the most brilliant stars in our own night sky. We are approaching the downtown core of the Milky Way, a region known as the galactic bulge. At the very center of this bulge is a feature we could not see clearly until our infrared telescopes pierced through the obscuring dust. A dense, elongated, the bar-like structure. This is the shimmering central bar of our galaxy. This bar is not a solid object, but a massive, tightly packed collection of stars, perhaps 20,000 light-years in length. Unlike the spiral arms, which are filled with young, hot blue stars, the central bar is composed mainly of older, cooler, and redder stars. These are ancient suns, many of them billions of years older than our own. Their collective light gives the galactic center a soft, golden-red hue. The stars here are on different kinds of orbits than the stars in the disk. Instead of moving in calm, circular paths, they tend to follow highly elongated, rosette-shaped orbits, swooping in close to the center and then back out again. This dynamic, organized motion of billions of old stars is what creates and sustains the bar structure. This central bar is a place of immense gravitational power and activity. It acts like a giant cosmic funnel, channeling gas and dust from the inner parts of the galactic disk inward, toward the very center. This steady flow of material can sometimes trigger bursts of new star formation in the regions around the bar, creating a ring of stellar nurseries that encircles the core. Floating here, in the midst of this dense, ancient golden light, would be an experience of profound awe. The sheer number of stars would be overwhelming, a continuous field of light in every direction. It is the old beating heart of our galaxy, a place of immense mass and timeless beauty. It is the central hub from which the graceful spiral arms unfurl, the anchor point for the entire spinning structure. Understanding this central bar is key to understanding the galaxy as a whole, as it is the engine that drives much of the galaxy's evolution and structure. It is from this dense, glowing core that we will now journey to the most extreme and mysterious object at its very center. At the very heart of the galactic bar, At the precise gravitational center of our entire Milky Way galaxy lies an object of unimaginable density and power. It is completely invisible to our eyes, yet we can see its profound influence on everything around it. This is Sagittarius A, our galaxy's supermassive black hole. Let us not think of this object as a monster or a cosmic vacuum cleaner. Let us instead approach it as the silent, unseen heart that gives our galaxy its central organizing principle. A black hole is created when an immense amount of mass is squeezed into an incredibly small space. The gravitational pull of this object is so strong that nothing, not even light, can escape its grasp once it crosses a boundary known as the event horizon. Sagittarius A has a mass that is equivalent to about 4 million of our suns. Yet all of this mass is contained within a region of space that would easily fit inside the orbit of Mercury. This is a staggering level of density. We cannot see the black hole itself, as it emits no light. We can only detect its presence by observing its effects on the stars that orbit it. With our most powerful telescopes, we have been able to watch individual stars at the galactic center as they perform rapid, graceful, orbital dances around a single, unseen point of blackness. They whip around this central point at incredible speeds, some completing their orbits in just a few years. These precise, predictable orbits allow us to calculate the mass of the central object with great accuracy, confirming that it can only be a supermassive black hole. This silent heart is not a destructive force on a galactic scale. It is a stabilizing one. Its immense gravity is the anchor that holds the dense central bar of stars in place. It is the central pivot around which the entire galaxy slowly turns. The flow of gas that is channeled by the bar ultimately makes its way towards Sagittarius A, where it forms a swirling, hot accretion disk before finally crossing the event horizon and disappearing from our universe forever. This process can release incredible amounts of energy, making the galactic center a bright source of radio waves and X-rays. Yet, for all its power, it is a place of serene, gravitational certainty. It is the quiet, invisible foundation upon which our entire city of stars is built. It is the final, central point of our journey inward, the silent, beating heart of the Milky Way. Having visited the silent, gravitational anchor at the galaxy's core, let us now drift outward, away from the dense, golden light of the central bar, and into the grand, sweeping structures that define our galaxy's beauty, the spiral arms. If the central bar is the old downtown core of our cosmic city, the spiral arms are its vibrant, creative, and youthful suburbs. As we enter one of these arms, let us imagine the grand Scutum Centaurus arm. The character of the space around us changes completely. The sky here is not filled with old red stars, but with brilliant, dazzling blue-white giants. These are young, massive, and incredibly hot stars, many of them only a few million years old. Cosmic infants compared to our 4.5 billion-year-old sun. The spiral arms are the birthplaces of stars. They are density waves, regions where the gas and dust of the galactic disk are compressed as they move through. This compression is the trigger that causes vast clouds of interstellar gas, known as nebulae, to collapse under their own gravity and ignite into new stars. As we drift through the arm, we would see these magnificent stellar nurseries all around us. We would see vast, colorful clouds of glowing hydrogen gas, illuminated from within by the fierce ultraviolet light of the newborn stars. We would see dark, dense lanes of cosmic dust, the raw material from which future stars and planets will be formed. The spiral arms are dynamic, energetic, and incredibly beautiful places. They are where the galaxy is constantly renewing itself, recycling old material into new generations of stars and solar systems. The massive, blue stars that are born here live fast and die young. They burn through their nuclear fuel in just a few million years before exploding in spectacular supernovae. These explosions are incredibly important for the galaxy's ecosystem. They enrich the interstellar gas with heavy elements, the carbon, oxygen, iron, and other elements that were forged in the hearts of these stars. This enriched gas then cools, collapses, and forms a new generation of stars, this time with a ready supply of the raw materials needed to form rocky planets and, perhaps, life. Our own sun was likely born in a region like this, and the heavy elements that make up our planet and our very bodies were forged in the hearts of long-dead stars in these spiral arms. The arms are not just beautiful. They are the engines of galactic creation and chemical evolution. They are the flowing, vibrant rivers of life in our cosmic city. Our journey has taken us to the dense, ancient core of the galaxy and through its vibrant, creative spiral arms. Now, let us gently pull our perspective back and return to our own familiar place in this grand structure. We drift out of the bustling Sagittarius arm and across a relatively dark, empty space and back into our home, the much quieter and smaller Orion Spur. This is where our sun resides, in what can be considered the galactic suburbs. Our location, about 2/3 of the way out from the center, is a place of relative peace and quiet. We are not in the chaotic, high-radiation environment of the galactic core, nor are we in the midst of the intense star formation and frequent supernovae of a major spiral arm. Our position is serene. The stars are more spread out here. The interstellar gas is less dense, and the cosmic traffic is much lighter. This suburban location may have been crucial for the development of life on Earth. It has provided a long, stable, and relatively undisturbed environment for billions of years, allowing life the time it needed to evolve from simple cells into complex creatures. We are far enough from the galactic center to be safe from the intense gravitational forces and radiation that would be hostile to life. We are also not in a major spiral arm, meaning we are less likely to pass near a massive star that could go supernova and sterilize our planetary system. We are, in a sense, in the galaxy's habitable zone. From this quiet vantage point, we have a beautiful view of the grander galactic structure. On a clear night, we can look inward and see the bright, dense band of the Sagittarius arm and the shimmering glow of the distant core. We are part of the city, but we are not lost in its overwhelming center. This perspective of seeing our home as a quiet place in the grand scheme of the galaxy is both humbling and comforting. It connects the vast, impersonal structures we have explored back to our own specific, familiar place within the cosmos. It gives us a sense of belonging not to a chaotic universe, but to an ordered, structured, and beautiful cosmic city in a neighborhood that is just right for a world like ours. We have now explored the grand, flat disk of our galaxy, from its core to its spiral arms. But the Milky Way is more than just this shimmering, spinning plate of stars. To truly understand its full form, we must now journey upward, leaving the familiar plane of the disk behind and venturing into the vast, spherical and ghostly realms that lie above and below it. Our journey now takes us on a gentle, upward drift, perpendicular to the galactic plane. As we rise, the familiar river of the Milky Way's disk begins to compress below us, transforming from a band across the sky into a brilliant, swirling vortex of light. We are ascending into a new and profoundly different environment, the galactic halo. The halo is a vast, roughly spherical cloud of stars and gas that envelops the entire galactic disk like a huge ethereal atmosphere. The density of stars here is incredibly low. If the galactic disk is a bustling, flat city, the halo is the vast, empty countryside that surrounds it for thousands of light years in every direction. The stars here are lonely wanderers, separated from their nearest neighbors by immense distances. The character of these halo stars is also different. They are almost exclusively very old. Ancient stars, among the first generations of stars to form in our galaxy's history, over 10 billion years ago. They are known as population 2 stars, and they are very poor in heavy elements. They formed from the pristine hydrogen and helium gas that existed in the early universe, before many supernovae had had a chance to enrich the cosmos with heavier materials. These ancient stars are not confined to the flat plane of the disk. Instead, they follow long, looping, eccentric orbits, plunging down through the disk and then soaring high out into the halo again, like celestial comets on billion-year journeys. Their random crisscrossing paths are a remnant of the chaotic early days of the galaxy's formation, before everything settled into the calm, dot-orderly rotation of the disk we see today. Floating in this vast, quiet sphere, the silence is even deeper than the space between the arms. The light from the galactic disk below us provides a soft, beautiful illumination but the space around us is mostly empty. The halo is a place of ancient memory, a ghostly attic of our galaxy, filled with its oldest and most venerable stellar citizens. It is a whisper of what the Milky Way once was, a chaotic jumble of gas clouds and star clusters, before it flattened and organized itself into the majestic spiral we know today. Exploring this serene, empty sphere gives us a sense of the galaxy's true three-dimensional scale and its deep, long history. It is the quiet, spherical embrace that holds our entire galactic city. As we drift through the vast, sparse emptiness of the galactic halo, we occasionally encounter objects of breathtaking beauty and antiquity. These are the globular clusters, and they are like ancient, self-contained cities of stars, floating in the lonely darkness. A globular cluster is a perfectly spherical, tightly packed collection of hundreds of thousands, or even millions, of stars. They are gravitational marvels, so dense that at their core, the stars are packed tens of thousands of times more closely than the stars in our own solar neighborhood. If you were on a planet in the heart of a globular cluster, the night sky would be a solid, blazing canopy of starlight, with thousands of stars shining as brightly as the full moon. Like the individual stars of the halo, the globular clusters are incredibly old. They are cosmic fossils, relics from the very dawn of our galaxy. The stars within them are all of the same ancient metal-poor generation. They were all born together, in a single massive burst of star formation, more than 12 billion years ago. Since then, they have held together as a single gravitationally bound entity, slowly orbiting the galactic center in the vast expanse of the halo. There are about 150 of these beautiful ghost-like clusters associated with our Milky Way. They float like lonely snow globes in the galactic attic, each one a perfectly preserved sample of the early universe. Their spherical shape comes from their own powerful collective gravity, which pulls all of their member stars into the most compact and stable configuration possible. They are incredibly stable structures, having survived countless trips through the disruptive plane of the galactic disk over the eons. Gazing upon a globular cluster from a distance is a serene and humbling experience. It is a single, shimmering jewel of concentrated starlight against the deep black of the halo, a silent testament to the enduring power of gravity and the immense age of our home galaxy. They are the oldest and most beautiful structures in the Milky Way, the quiet, venerable elders of our galactic family. Our journey through the halo has shown us its visible components, the scattered ancient stars and the magnificent globular clusters. But now, we must turn our attention to what we cannot see. The most profound and mysterious aspect of the galactic halo is that the vast majority of its mass is completely invisible to us. The stars we see, both in the halo and in the bright disk, are moving much faster than they should be. The gravity of all the visible matter in the galaxy, all the stars, gas, and dust combined, is not nearly strong enough to hold on to these fast-moving stars. Our galaxy should be flying apart. The fact that it is not, the fact that it is a stable, cohesive structure, tells us that there must be a huge amount of extra mass present, a mass that we cannot see, which provides the extra gravitational glue needed to hold everything together. This mysterious, unseen substance is what scientists have named dark matter. Dark matter does not emit, absorb, or reflect any kind of light. It is not just dark in the sense of being dim. It is completely and utterly transparent to all forms of electromagnetism. It does not interact with normal matter in any way we can detect, except through the gentle, persistent pull of its gravity. We do not yet know what dark matter is, but we know that it is all around us. The halo of our galaxy, which appears so empty, is actually a vast, massive sphere of this invisible substance. The visible galaxy, the beautiful spiral disk and the scattered halo stars, are like a light dusting of cosmic foam on the surface of a deep, unseen ocean of dark matter. It is estimated that dark matter outweighs all the normal visible matter in our galaxy by a factor of about 5 to 1. Let us try to feel this presence. As we float in the halo, imagine that the space around us, which seems so empty, is actually filled with a fine, invisible substance. It exerts no pressure, it has no temperature, but it has weight. It is a silent, unseen gravitational scaffolding upon which our entire galaxy is built. The dark matter halo formed first in the early universe, a vast, invisible cloud of mass. Then, the normal matter, the hydrogen and helium gas, was drawn in by the gravity of this dark matter cloud, and it settled into the center to form the spinning disk of stars that we see today. So, our visible galaxy exists only because it is cradled within this much larger, more massive, and completely invisible halo of dark matter. This is a deeply humbling realization. The beautiful city of stars we have been exploring is just the visible, luminous tip of a much larger and more mysterious iceberg. The universe is not what it appears to be, and its truest nature may be forever hidden from our sight, felt only through the quiet, persistent pull of its gravity, as we float high above the galactic plane, within the vast, invisible sphere of the dark matter halo. Let us now turn our gaze outward, into the intergalactic space that surrounds our home. From this high vantage point, we can see that our Milky Way is not entirely alone. Hanging in the darkness, at a distance of about 160,000 light-years, are two hazy, irregular patches of light. They look like two detached, luminous clouds from our own galaxy. And indeed, for a long time, that is what they were thought to be. These are the Large and Small Magellanic Clouds, and they are, in fact, two smaller galaxies in their own right. They are our closest galactic neighbors, two satellite dwarf galaxies that are gravitationally bound to our much larger Milky Way. The Large Magellanic Cloud is the bigger and brighter of the two. It is an irregular galaxy, meaning it lacks the beautiful, ordered spiral structure of our own. It is a more chaotic and patchy collection of stars, gas, and dust. But it is a place of incredible vitality. It is currently undergoing a period of intense star formation, with many brilliant blue star clusters and glowing pink nebulae visible across its expanse. One of its nebulae, the Tarantula Nebula, is the most active star-forming region in our entire local galactic neighborhood, a vast and spectacular stellar nursery. The Small Magellanic Cloud is further away and, as its name suggests, smaller and fainter. It too is an irregular dwarf galaxy, a quiet, humble companion to its larger sibling and to our own Milky Way. Together, these two galaxies are like small celestial boats floating just off the coast of our grand continental island of a galaxy. Seeing them from our perspective in the halo gives us a new sense of context. Our galaxy is not just an isolated island universe. It is the dominant member of a small, local system. It has companions, satellites that are caught in its immense gravitational field. This is the first hint that galaxies themselves are not randomly scattered throughout the universe, but are often found in groups and clusters, bound together by their mutual gravity. The Magellanic Clouds are the first members we have met of our larger, extended galactic family. The relationship between our Milky Way and the Magellanic Clouds is not a static one. These three galaxies are locked in a slow, graceful, and deeply transformative gravitational dance that has been unfolding over billions of years. From our quiet perch in the halo, we can almost see the evidence of their long interaction. A vast, sweeping trail of hydrogen gas, known as the Magellanic Stream, has been pulled out of the dwarf galaxies by the powerful tidal forces of the Milky Way. This stream arcs across a huge portion of the sky, a ghostly, invisible bridge that connects the clouds to our galaxy. It is a testament to the immense gravitational power of our home galaxy, which is slowly siphoning gas away from its smaller companions. This process is not entirely one-sided. The Magellanic Clouds are on an orbital path that is bringing them closer to our galaxy. Current models suggest that they are likely on their first pass around the Milky Way, and that their dance is destined to end in a magnificent merger. Over the next few billion years, the two smaller galaxies will be completely torn apart and absorbed by the Milky Way. Their stars, gas, and dust will be assimilated into our own galaxy, becoming part of its halo and disk. This is not a violent collision in the traditional sense. Stars are so far apart that individual stars will almost never hit each other. Instead, it is a slow, gentle merging of gravitational fields, a blending of stellar populations. This process of galactic cannibalism, where large galaxies grow by absorbing smaller ones, is a fundamental part of how galaxies evolve throughout the universe. Our Milky Way is still growing, and the Magellanic Clouds are its next meal. Seeing this slow, silent, and creative dance of gravity transforms our view of these three objects from isolated islands into a single, interactive, and evolving system. It is a beautiful, large-scale example of the patient, creative power of gravity. This understanding of galactic interaction provides a perfect, seamless transition to the next chapter of our journey, where we will zoom out even further to see our Milky Way and its companions as part of an even larger family of galaxies. With the image of the slow gravitational dance between our galaxy and its companions fresh in our minds, let us now take our next great leap outward. We drift away from the Milky Way's halo, leaving behind the Magellanic Clouds, and venture into the true deep space that lies beyond. This is the intergalactic void, the immense, quiet chasm that separates one galaxy from the next. The emptiness here is even more profound than the emptiness of interstellar space. The density of matter drops to just a few atoms per cubic meter. The silence and the darkness are more complete. As we drift further away, our home galaxy, the Milky Way, shrinks behind us. Its grand, spiral form becomes more and more apparent, a beautiful, luminous pinwheel of light hanging in the absolute blackness. Soon, the Magellanic Clouds merge with its light, becoming just a faint, hazy extension of its glow. This is a perspective that inspires a unique kind of awe. For the first time, we are seeing our entire galactic home as a single object, an island of light in an endless ocean of dark. This island contains hundreds of billions of stars, countless planets, and the entire history of our species. But from out here, it is just one solitary point of organized matter, in a universe defined by its emptiness. The distances we are now dealing with are measured in millions of light years. The gap between our galaxy and its next major neighbor is more than 20 times larger than the diameter of our galaxy itself. This vast, dark, and quiet ocean is the normal state of the universe. The galaxies are the exceptions, the rare and beautiful places where matter has managed to congregate. Floating in this peaceful void, we feel a sense of serene detachment. We are no longer citizens of a planet or a star system, but observers of the cosmos on its grandest scale. We are waiting patiently for the next shore to appear in the distance. The light from other galaxies travels across this void for millions of years, carrying with it the story of its home. As we look around, we begin to see other faint, fuzzy patches of light in the distance. Each one is another galaxy, another island universe like our own. We are now prepared to see that our Milky Way is not alone, but is part of a larger archipelago, a local group of galaxies, all adrift together in this same quiet cosmic sea. Having journeyed into the profound quiet of the intergalactic void, we now find that we are not adrift and alone. Our galaxy is part of a larger family, a small, gravitationally bound cluster of galaxies. This is our extended home, our cosmic neighborhood, known as the local group. As we float in the space just outside our Milky Way, we can now begin to perceive the structure of our local galactic neighborhood. The local group is not a dense, crowded cluster, but a small and spacious collection of over 50 galaxies, all occupying a region of space about 10 million light-years in diameter. Let us frame this not as a group, but as a peaceful, gravitationally bound archipelago. In this archipelago, there are two large continental landmasses, and then a scattering of much smaller islands and islets. Our own Milky Way is one of these two great continental galaxies. The other, as we shall soon see, is the Andromeda Galaxy. These two giants dominate the local group, each with its own system of smaller, satellite galaxies orbiting it. The rest of the local group's population consists of these smaller dwarf galaxies. We have already met the two most prominent ones, the large and small Magellanic Clouds, which are satellites of our own Milky Way. But there are many others, most of them much fainter and more diffuse. There are dwarf spheroidal galaxies, which are like faint, ghostly versions of globular clusters, and dwarf irregular galaxies, similar in their chaotic structure to the Magellanic Clouds. These humble dwarf galaxies are the most common type of galaxy in the universe, and they make up the vast majority of our local group's population. They float in the intergalactic space between the Milky Way and Andromeda, some as loyal satellites to the giants, others as more independent, lonely travelers. The entire archipelago is held together by the mutual gravity of its members. They are all moving through space together as a single, cohesive unit. The space between the galaxies in the local group is not truly empty. It is filled with a very thin, hot gas, a tenuous intergalactic medium that has been heated by the radiation from the galaxies themselves. Thinking of our cosmic home in this way, as a serene archipelago, gives us a new sense of place. We are not just on a single island, the Milky Way, but we are part of a larger, interconnected chain of islands, a defined and peaceful region in the vast, open ocean of the universe. This is our local family, a quiet and spacious community of galaxies, our home on the next scale up. Now, let us embark on the longest journey we have yet imagined. Let us travel across the vast, dark and quiet sea of the local group, from our own Milky Way to its twin, its rival, its sister galaxy. This is the Andromeda Galaxy, also known as Messier 31. The journey covers a distance of 2.5 million light-years. The light we see from this galaxy tonight began its journey toward us 2.5 million years ago, at a time when early human ancestors were just beginning to walk the plains of Africa. For all of that time, the photons of light from Andromeda have been traveling, patiently, across the immense, dark chasm that separates our two galaxies. As we drift across this space, our own Milky Way shrinks behind us to a bright, spiral smudge, and the faint, oval glow of Andromeda grows ever larger ahead of us. As we arrive, we are greeted by a sight of stunning and familiar beauty. Andromeda is, like our own galaxy, a magnificent spiral galaxy, but it is noticeably larger, grander, and more massive than the Milky Way. If our galaxy is a beautiful city, Andromeda is a sprawling, majestic metropolis. It is estimated to be about 220,000 light-years across, more than twice the diameter of our own galaxy. And while our Milky Way contains somewhere between 100 and 400 billion stars, Andromeda is thought to contain as many as 1 trillion. It is the undisputed queen of the local group, the largest and most massive member of our galactic family. Looking at Andromeda is like looking in a cosmic mirror. It gives us a precious, outside perspective on what our own Milky Way might look like to a distant observer. We can see its structure with a clarity that we can never have of our own galaxy from our position inside it. We see its bright central bulge, which is thought to harbor an even larger supermassive black hole than our own, perhaps 100 million times the mass of our Sun. We see its 2 major, tightly wound spiral arms, glowing with the blue light of young stars, and traced with the dark, elegant lanes of cosmic dust. And we see its vast, extended stellar halo, which is so large that it may already be starting to touch the outer edges of our own galaxy's halo. Surrounding Andromeda is its own family of satellite dwarf galaxies, just as our Milky Way has its own. It is the center of its own gravitational dynasty within the local group. This majestic, serene, and awe-inspiring galaxy is our sister, our companion in the long, slow waltz of cosmic time. It is a humbling and beautiful thing to know that our closest major neighbor is such a magnificent reflection of our own galactic home. After marveling at the 2 giants that dominate our local group, the Milky Way and Andromeda, let us now turn our attention to the 3rd and final significant member of our galactic archipelago. About 3 million light-years from our Sun, and a bit closer to Andromeda, is the Triangulum Galaxy, also known as Messier 33. It serves as a beautiful point of contrast to the 2 behemoths of our group. Triangulum is also a spiral galaxy, but it is much smaller, more modest and more delicate than either the Milky Way or Andromeda. It has a diameter of about 60,000 light-years and contains around 40 billion stars, making it only about 1/10 as massive as our own galaxy. What makes Triangulum so special is its beautiful, open, and flocculent spiral structure. Unlike the grand, well-defined arms of Andromeda, Triangulum's arms are more patchy, fluffy, and less distinct, like tufts of celestial cotton. It also lacks a prominent central bulge and a bar, giving it a more pure, pinwheel-like appearance. It is a serene and understated beauty compared to its larger neighbors. Triangulum is a site of very active star formation. It is filled with enormous glowing clouds of hydrogen gas, and some of the largest and most massive stellar nurseries known in the local group are found within its delicate arms. Its light is dominated by the brilliant blue-white glow of these vast regions of stellar birth. Its position and motion suggest that it may be a distant, gravitational companion to the larger Andromeda galaxy, much like the Magellanic Clouds are to our Milky Way. It is the third point in the quiet gravitational dance that defines the heart of our local group. Seeing this smaller, more gentle spiral galaxy helps us appreciate the diversity of forms that galaxies can take, even within a single, small group. They are not all monolithic giants. There are also these more modest, but equally beautiful island universes. Triangulum completes the trio of spiral galaxies that form the core of our local family, a quiet, creative, and beautiful neighbor in our small patch of the cosmos. We have now met the three most prominent citizens of our local group, the two giants, Milky Way and Andromeda, and the modest spiral of Triangulum. But to truly understand our neighborhood, we must now turn our attention to its most numerous yet most humble residents, the dwarf galaxies. These are the small, faint, and often overlooked companions that make up the vast majority of the local group's population. There are more than 50 of these small galaxies known, and astronomers suspect that many more, even fainter ones, are still waiting to be discovered, hiding in the darkness between their larger siblings. These dwarf galaxies come in a few different forms. There are the dwarf irregulars, like the Magellanic Clouds, which are messy, chaotic collections of gas and stars, often buzzing with active star formation. Then there are the dwarf spheroidals, which are the most common type. These are very faint, diffuse, and ghostly objects. They are composed almost entirely of old stars and have very little gas or dust left in them, meaning they are no longer forming any new stars. They are quiet, ancient, and retired galaxies, serene collections of old starlight. Finally, there are the even smaller and fainter ultra-faint dwarf galaxies, which are so sparse that they are incredibly difficult to detect, some containing only a few thousand stars in total. They are the true ghosts of the galactic world. Most of these dwarf companions are clustered around the two giants, the Milky Way and Andromeda, like a swarm of bees around their hives. Our own galaxy has about 24 known satellite galaxies, including the Magellanic Clouds and the much fainter Sagittarius dwarf galaxy, which is currently in the process of being torn apart and absorbed by the Milky Way. Andromeda has a similar number of companions, including the two bright, compact elliptical galaxies, Messier 32 and Messier 110, that are clearly visible in photographs of their giant parent. These small galaxies are the building blocks of the larger ones. Over cosmic time, many of these dwarf companions will spiral inward and merge with their parent galaxies, contributing their stars and dark matter to the growth of the giants. By studying these humble, quiet companions, we can piece together the history of our local group and understand how galaxies like our own were assembled, piece by piece, over billions of years. They are the quiet, unassuming majority of our cosmic archipelago. As we float in the quiet space of our local group, surrounded by its family of galaxies, we become aware of a slow, inevitable, and majestic event that is currently unfolding. The two great giants of our group, our own Milky Way and the even larger Andromeda galaxy, are not stationary. Due to their mutual, powerful gravitational attraction, they are hurtling towards each other at a speed of about 250,000 miles per hour. This is not a cause for alarm, but rather a cause for quiet, cosmic wonder. We are witnessing the beginning of a long, slow, and beautiful galactic merger, a creative dance that will reshape our entire local neighborhood. This collision, which will begin in earnest in about 4.5 billion years, should not be imagined as a violent, destructive crash. Because the distances between individual stars are so immense, it is incredibly unlikely that any two stars will actually collide. Instead, this will be a collision of gravitational fields. As the two galaxies begin to interpenetrate, their beautiful flat spiral disks will be twisted, warped, and eventually destroyed by the powerful tidal forces. Long, graceful streamers of stars and gas, known as tidal tails, will be flung out into intergalactic space, creating a spectacular, temporary celestial artwork. The two supermassive black holes at the centers of the galaxies will sink toward the new, combined center, and eventually merge in a process that will send out powerful ripples in the fabric of space-time, known as gravitational waves. Over hundreds of millions of years of this slow gravitational mixing, the two spiral galaxies will merge into a single, much larger galaxy. The gas and dust from both will be compressed, triggering a massive, galaxy-wide burst of star formation, a brilliant starburst that will illuminate the new creation. After this burst has subsided and the chaotic motions have settled down, the final result will be a single giant elliptical galaxy. This new galaxy, sometimes nicknamed Milky Way, will be a vast reddish spheroidal collection of older stars, with very little gas or dust left for new star formation. It will be a calm, mature and retired galaxy. This serene long-term future connects the present state of our local group to its ultimate destiny. It is a beautiful reminder that the universe is not static, but is a place of constant, slow and creative evolution, all choreographed by the patient, gentle and inescapable hand of gravity. Our journey has revealed our place in a local family of galaxies, but this small, quiet archipelago is itself just a tiny, insignificant suburb of a much larger cosmic city. We must now zoom out once again, to a scale so vast that our entire local group becomes just a single point of light. We are entering the realm of superclusters. To understand our place on the next scale up, we must first appreciate the largest known structures in the entire universe. As astronomers began to map the positions of millions of galaxies in 3 dimensions, a stunning and unexpected picture emerged. Galaxies are not scattered randomly throughout space like dust motes. Instead, they are organized into a vast, intricate and beautiful pattern, a cosmic lacework of unimaginable scale. This structure is known as the cosmic web. Imagine a 3-dimensional spider's web, vast enough to fill the entire observable universe. The cosmic web consists of long, thin, glowing filaments of galaxies and dark matter, stretching for hundreds of millions of light years. Where these filaments intersect, they form dense, massive knots, which are the great clusters of galaxies, cosmic cities containing thousands of galaxies packed closely together. The spaces in between the filaments and clusters are the great cosmic voids, immense, nearly empty bubbles of space, some of them hundreds of millions of light years across, where very few galaxies are found. This beautiful, web-like structure is a natural consequence of gravity acting over cosmic time. In the very early universe, matter was distributed almost, but not quite, perfectly smoothly. There were tiny quantum fluctuations, regions that were infinitesimally denser than others. Over billions of years, gravity has amplified these tiny initial density differences. The slightly denser regions have pulled in more and more matter, collapsing to form the filaments and clusters of the cosmic web, while the less dense regions have emptied out to become the great voids. The galaxies, including our own, were born and live their lives within the dense filaments of this web. The cosmic web is the grand underlying architecture of the universe, the skeleton upon which all visible structure is built. Our local group is just one tiny, insignificant collection of galaxies, located somewhere within one of these great cosmic filaments. We are not in a dense cluster, nor are we in a desolate void. We are in a relatively quiet, suburban part of a cosmic filament. Understanding this grand structure is essential for our next step. It provides a new framework, a new map for understanding the universe's layout. We are no longer thinking about individual galaxies or small groups, but about vast, interconnected rivers and continents of galaxies, all part of a single coherent, universal structure. Let the quiet, profound image of this immense, glowing web fill your mind. It is the largest pattern in nature, a serene testament to the patient, organizing power of gravity over 14 billion years. Now that we have the grand map of the cosmic web in our minds, let us zoom into our own particular province within this web. Our local group, along with several other nearby groups and clusters of galaxies, is part of a much larger, flattened, filamentary structure known as the Virgo supercluster. If our local group is a small, quiet suburban cul-de-sac, the Virgo supercluster is the entire metropolitan area to which we belong. This immense structure is about 110 million light-years across and contains at least 100 different galaxy groups and clusters. Its total mass is staggering, perhaps more than a quadrillion times the mass of our Sun. The Virgo supercluster is not a single gravitationally bound object in the same way a galaxy cluster is. Instead, it is a vast, overdense region of the universe, a significant concentration of galaxies that stands out against the relative emptiness of the surrounding voids. It is a filament, a river of galaxies, and we are a part of it. The name comes from the fact that its gravitational center is dominated by a huge, rich cluster of galaxies called the Virgo cluster, which lies in the direction of the constellation Virgo. All the other groups and clusters in the supercluster, including our own local group, are arranged in a sort of flattened, pancake-like structure, all feeling the gravitational influence of the massive Virgo cluster at the heart. By recognizing our membership in the Virgo supercluster, we are establishing a new, mind-boggling scale for our cosmic address. We live on Earth, which is part of the solar system. The solar system is in the Orion spur of the Milky Way galaxy. The Milky Way is one of the 3 largest galaxies in the local group, and the local group is a small, outlying member of the great Virgo supercluster. Each step outward has revealed a new, larger structure to which we belong. We are not lost in a random cosmos, but are part of a deeply nested and organized hierarchy of structures, all shaped by gravity. This realization brings a sense of serene order to the universe's immense complexity. We have found our metropolitan area in the cosmic web. Our journey now takes us from our quiet, outlying position in the Virgo supercluster and brings us toward its gravitational heart, its bustling, downtown core. This is the Virgo cluster, a massive and dense collection of over 1,300 galaxies, located about 54 million light-years from us. This is a true cosmic city, a place of incredible density and activity compared to the peaceful quiet of our own local group. As we approach the cluster, the number of galaxies in our field of view increases dramatically. Instead of seeing 1 or 2 galaxies at a time, we now see dozens, then hundreds, all packed into a relatively small region of space. The Virgo cluster is a mature and well-established city of galaxies. At its very heart are not spiral galaxies like our own, but 3 enormous giant elliptical galaxies, Messier 87, Messier 86, and Messier 84. These behemoths are the result of countless galactic mergers over billions of years. They are vast spheroidal collections of old red stars, and they each likely contain trillions of suns. Messier 87 is particularly famous for housing a supermassive black hole at its center that is over 6 billion times the mass of our Sun, one of the most massive black holes known. In 2019, this was the first black hole ever to be directly imaged by the Event Horizon Telescope. The space between the galaxies in the Virgo cluster is not empty. It is filled with an incredibly hot, diffuse gas, heated to millions of degrees, which is visible to our X-ray telescopes. This is the intracluster medium, a remnant of the gas stripped from galaxies as they fall into the cluster's powerful gravitational field. The galaxies here are in constant dynamic motion, swarming around the cluster's center of mass like bees in a hive. The environment is too chaotic and disruptive for delicate spiral galaxies to survive for long. As they fall into the cluster, their gas is stripped away, and they are gravitationally harassed by their neighbors, eventually transforming them into less structured lenticular or dwarf elliptical galaxies. The Virgo cluster is a galaxy graveyard and a transformation center, a place where galaxies are profoundly changed by their environment. It is the great, dense, metropolitan heart of our home supercluster. Having witnessed the dense, chaotic heart of the Virgo cluster, let us now pull back our perspective to see the supercluster as a dynamic, the flowing system. The galaxies and groups within the Virgo supercluster are not just sitting statically in space. They are all participating in a grand, collective motion, a cosmic flow. The immense mass of the Virgo cluster at the center exerts a powerful gravitational pull on everything else in the supercluster, including our own local group. As a result, our local group, and all the other surrounding galaxy groups, are not just expanding away from each other due to the overall expansion of the universe. We are also all being gently pulled toward the Virgo cluster. This motion is sometimes called Virgo-centric flow. Imagine the supercluster as a vast, shallow basin. The Virgo cluster is the lowest point at the center of the basin. All the other galaxy groups are like marbles scattered on the sloped sides of the basin, and they are all slowly, inevitably rolling downhill toward the center. Our own local group is currently moving toward the Virgo cluster at a speed of several hundred kilometers per second. This is not a collision course in the simple sense, but rather a slow, gravitational infall that has been happening for billions of years and will continue for billions more. We are part of a great cosmic river of galaxies, all flowing toward the same massive central reservoir. This image of a dynamic, flowing system adds a beautiful, living quality to our picture of the supercluster. It is not a static collection of objects, but a coherent, evolving structure defined by this shared, large-scale motion. It reinforces the idea that gravity is the great, patient sculptor of the universe, not just forming individual galaxies, but also choreographing the dance of these galaxies on the largest of scales. We are not just residents of the Virgo supercluster. We are participants in its grand, slow, and serene gravitational flow. This shared motion, this sense of being part of a cosmic current, is a profound and peaceful way to understand our connection to this vast, celestial structure. We now drift away from the central Virgo cluster and out toward the far edge of our home supercluster. The journey covers tens of millions of light years. As we move further out, the density of galaxies begins to drop off significantly. The river of galaxies thins out into a trickling stream, and then finally we reach the shore. We are at the boundary where the Virgo supercluster ends and the next great cosmic void begins. Looking back from this vantage point, we can appreciate the full scale of the structure we have just explored. We see the dense, bright knot of the Virgo cluster at its heart, and the long, flattened, filamentary collection of other galaxy groups, including our own, trailing away from it. The entire structure stands out as a luminous continent of light against the profound, dark emptiness of the void that lies beyond. This edge is not a sharp, well-defined line, but a gradual tapering off. It is a region where the gravitational influence of the Virgo cluster begins to fade, and the overall, uniform expansion of the universe becomes the dominant motion once again. To be here, at the quiet, lonely edge of our supercluster, is to feel a sense of profound perspective. We have traveled from our home, our tiny island, across the archipelago of our local group, and across the entire continent of our supercluster, to stand on its final distant shore. It is a place of serene transition, a boundary between the something of our cosmic home and the nothing of the great void. This final panoramic view of the Virgo supercluster, our home on the grandest scale we have yet known, gives us a sense of closure on this part of our journey. We have seen its bustling center, felt its gravitational flow, and now we rest at its peaceful edge. But as we look out into the void, we see other, impossibly distant filaments and superclusters on the far shore. This sight prepares us for the next, and perhaps most mind-boggling realization, that even this colossal structure, this city of thousands of galaxies, is just one of many, and is itself part of an even larger, more profound structure that we are only just beginning to understand. Resting here at the quiet edge of the Virgo supercluster, we look out across the great cosmic void and see, in the far, far distance, the faint light of other superclusters. They appear as other long, glowing filaments, other vast continents of galaxies, separated from ours by immense oceans of emptiness. This is the moment we realize that our home supercluster, which seemed so unimaginably vast, is not unique. It is just one component in the all-encompassing cosmic web. The universe is a tapestry woven from these supercluster filaments. This realization is as profound as the moment an early islander first realized that their island was just one of many in a world-spanning ocean. Our Virgo supercluster is just our local province in a much larger cosmic kingdom. For a long time, it was thought to be the largest gravitationally coherent structure to which we belonged. But in recent years, a new and even grander picture has emerged. By studying the peculiar motions of galaxies, not just in our supercluster but in all the neighboring ones as well, scientists have been able to map the gravitational flows on an even larger scale. What they discovered was that our Virgo supercluster is not an isolated continent. It is in fact just a small peninsula, a minor outlying lobe of a much larger supercluster structure. This discovery has forced us to redefine our cosmic address once again. We are part of something even more immense, something whose scale challenges the very limits of our imagination. The understanding that our supercluster is just one among countless many, and that it is itself just a small part of an even greater whole, sets the stage for the final and most profound zoom out of our journey. We are about to be introduced to our true home continent in the cosmic web, a structure so vast and so massive that its name, Laniakea, means immeasurable heaven in the Hawaiian language. Our journey through the Virgo supercluster has been but a walk through one of the smaller regions of this immeasurable celestial kingdom. We stand at the edge of what we thought was our home, the Virgo supercluster, only to find that it is but a small part of a far grander system. A new map of the cosmos has been drawn, one based not on the positions of galaxies but on their motion. We now enter our true home continent, the Laniakea supercluster. For many years, our cosmic address ended with the Virgo supercluster. We believed it was the largest structure to which we belonged. But in the year 2014, a new way of defining these large-scale structures was introduced, and it changed everything. Instead of simply grouping galaxies together based on how close they are to each other, a team of astronomers decided to define superclusters based on the direction of their flow. They mapped the velocities of thousands of galaxies in our cosmic neighborhood, subtracting the overall expansion of the universe to reveal their peculiar motions, the motions caused by the gravitational pull of nearby structures. What they found was a stunning revelation. They discovered a vast region of space, over 500 million light-years in diameter, within which all the galaxies are moving toward a single, common gravitational valley. This vast basin of attraction is our true home supercluster, and they named it Laniakea. This new definition means that our old Virgo supercluster is not a standalone structure at all. It is merely a small, outlying lobe of the much larger Laniakea. We are not living on a small continent. We are living in one of the coastal regions of a supercontinent. This redefinition of our address is profound. A supercluster is now defined not as a simple concentration of matter, but as a watershed. Think of rainfall on a continent. The water that falls on one side of a continental divide will flow into one ocean, while the water on the other side will flow into another. Laniakea is a cosmic watershed. All the galaxies within it, including our own Milky Way, are flowing downhill toward the same central point. The boundary of Laniakea is the line where this cosmic flow divides, where galaxies on the other side begin to flow away from us, toward a different supercluster's basin of attraction. This new understanding places us within a structure that is almost 5 times larger than what we previously thought of as our home supercluster. Laniakea contains the mass of roughly 100,000 Milky Way galaxies, and it encompasses not just the Virgo supercluster, but also several other major superclusters and voids. Our entire cosmic neighborhood has been recontextualized. We are part of a single, coherent and immense structure, all bound together by a shared gravitational destiny. This is not just a larger box to put ourselves in. It is a more meaningful, dynamic definition of home. It is a home defined by a shared journey, a collective, gentle and irresistible flow toward a single great unseen attractor. At the heart of the Laniakea supercluster, at the bottom of the vast gravitational valley toward which everything is flowing, lies a mysterious and immense concentration of mass. This is the gravitational center of our supercluster, a region known as the Great Attractor. For decades, astronomers have been aware of its presence because of its powerful gravitational influence on our local group and all the surrounding galaxies. We can measure our motion toward it, a significant pull that is superimposed on top of our motion toward the Virgo cluster. The Great Attractor is the ultimate destination for the cosmic river of galaxies that is Laniakea. The mystery of the Great Attractor comes from the fact that it is very difficult to observe directly. It lies in a direction of the sky that is obscured by the dense plane of our own Milky Way galaxy. This region is called the zone of avoidance, because the thick clouds of gas and dust in our galactic disk block the visible light from the galaxies that lie beyond it. It is like trying to see a distant mountain range through a thick, dense fog. However, by using radio and X-ray telescopes, which can pierce through the dust, astronomers have been able to peek into this hidden region. They have discovered a massive supercluster of galaxies, the Norma cluster, located right in the heart of the Great Attractor region. This cluster, however, is not massive enough on its own to account for the entire gravitational pull that we observe. It seems to be just one part of an even larger concentration of mass. The Great Attractor is not a single object, but a broad, diffuse, and incredibly massive region of the cosmic web where several large filaments are converging. It is the central gravitational nexus of our entire supercontinent of galaxies. It is not a cosmic monster pulling us into our doom. It is simply the largest and most massive concentration of matter in our part of the universe, and so it naturally forms the gravitational center of our Laniakea supercluster. It is the unseen heart of our immeasurable heavenly home, the quiet, massive presence that choreographs the gentle, cosmic flow of 100,000 galaxies. With the concept of Laniakea and its Great Attractor in our minds, let us now try to visualize the beautiful, large-scale motion that defines our supercluster. Let us imagine we can see the paths of all 100,000 galaxies within Laniakea, tracing their movements over billions of years. What we would see is a sight of profound and serene beauty. We would see countless streams and rivers of galaxies, all flowing from the outer, less dense regions of the supercluster and merging into larger and larger currents as they approach the center. The galaxies are not moving in straight lines, but are following the gentle, curved contours of the gravitational landscape, a landscape shaped primarily by the invisible scaffolding of dark matter. The cosmic web is not static. It is a dynamic, flowing system. Laniakea is a living, breathing part of that web. We would see our own local group, a tiny collection of specks, first feeling the pull of the nearby Virgo cluster. Our path would take us toward Virgo, but we would not stop there. The entire Virgo supercluster, which we once thought was our final destination, is itself just a tributary. We would see our entire Virgo filament flowing along a much grander arc, joining with other filaments, and all heading toward the much more massive Great Attractor region. It is a beautiful, nested hierarchy of flows. This visualization of the entire supercluster as a single, coherent watershed is a peaceful and powerful one. It removes the sense of chaos from the cosmos and replaces it with a sense of serene, large-scale order. The universe is not a random collection of objects, but a place of structure, flow, and evolution. Every galaxy has its place in this cosmic current. The motion is incredibly slow, unfolding over timescales of billions of years, a gentle cosmic drift that is imperceptible on a human lifespan, but is the dominant force shaping our corner of the universe. To feel ourselves as part of this grand, silent, and beautiful flow is to feel a deep and profound connection to the cosmos on its most majestic scale. Let us now gently zoom in and locate our own tiny, insignificant place within this immense cosmic flow. Our Milky Way galaxy, our home, is just a single speck of dust in this great river. We are one of 100,000 other specks, all carried along by the same gentle, inexorable current of gravity. Our motion through the cosmos is a complex and beautiful dance. Our planet spins on its axis and orbits the sun. Our solar system orbits the center of the Milky Way. Our Milky Way moves within the local group. And our entire local group is being pulled along in this great cosmic flow, this Virgo-centric infall that is itself part of the larger flow toward the Great Attractor. To know our place in this current is to achieve a new level of cosmic perspective. It can be humbling to realize our own insignificance on this scale, but it can also be deeply comforting. We are not isolated or lost. We are part of a grand, ordered, and beautiful procession. We are connected to every other galaxy in Laniakea by this shared gravitational destiny. The light from those distant galaxies may take hundreds of millions of years to reach us, but we are all part of the same cosmic river, all flowing toward the same deep, quiet pool. This perspective gives us a sense of serene belonging. The forces that guide our galaxy's path through the universe are the same forces that keep our feet on the ground. It is all the same gentle, patient, and universal law of gravity, acting on different scales. To rest in this understanding, to feel our small, quiet place in this vast, silent current, is a peaceful and meditative act. We are a part of the flow of the cosmos, and that is a beautiful and profound thing to be. We have now understood Laniakea as a great cosmic river, a watershed defined by a common flow toward the great attractor. But what defines the edge of a river? What is its boundary? For Laniakea, the boundary is a place of profound and beautiful subtlety. It is not a wall or an edge, but a gravitational divide. Imagine a mountain range. Rain that falls on one side of the crest will flow down into one valley, while rain that falls on the other side will flow down into a different valley. The crest of the mountain range is the divide, the boundary between the two watersheds. The boundary of Laniakea is a cosmic continental divide. If we could float in the space at the very edge of Laniakea, we would be in a region where the gravitational pull is perfectly balanced. A galaxy on our side of the line would feel a slightly stronger pull from the great attractor and would begin the long, slow journey to join our cosmic river. A galaxy just a little further out, on the other side of the line, would feel a slightly stronger pull from the heart of the neighboring supercluster, perhaps the Perseus-Pisces supercluster, and would begin to flow away from us, toward that other great basin of attraction. The boundary of Laniakea is a surface of gravitational equilibrium, a place of perfect, quiet balance in the cosmic tug-of-war. This is a beautiful and elegant way to define a structure. It is not based on how much stuff is in one place, but on where that stuff is going. It is a dynamic, living boundary. Visualizing this gives us a serene and definitive sense of our supercluster's true extent. We have traveled from its outer streams, through its tributaries like the Virgo supercluster, and toward its deep central basin at the Great Attractor. And now, we understand its peaceful, gravitationally defined shoreline. This final understanding of our immeasurable heavenly home provides the perfect launching point for our final, ultimate leap of scale to the edge of everything we can possibly see, the observable universe. We have journeyed from our planet to our supercluster, each step revealing a larger home. Now, we take the final, most profound leap. We pull our perspective back so far that even the mighty Laniakea becomes a single glowing thread in an infinitely larger tapestry. We are now going to explore the universe on its ultimate scale. As we float in the profound peace of inter-supercluster space, we must now confront a fundamental limit to our vision. We cannot see the entire universe. There is a horizon, an ultimate boundary to what we can ever hope to observe. This boundary is not a physical wall or an edge to space, but a horizon in time. The universe as we know it had a beginning. The Big Bang happened approximately 13.8 billion years ago. This means that the light from any object more than 13.8 billion light-years away has not yet had enough time to reach us. Therefore, we are surrounded by a vast, spherical bubble of visibility. This bubble is the observable universe. Its center is not a special place in the cosmos. Its center is us, the observer. Every observer in the universe has their own unique, spherical, observable universe, centered on themselves. The diameter of this sphere is not 13.8 billion light-years, but a much larger 93 billion light-years. This is because the universe has been expanding throughout its entire history. The space that the light has had to travel through has been stretching as the light made its long journey. So, an object that was 13.8 billion light-years away when its light was emitted is now much, much farther away from us. This vast, 93 billion light-year sphere represents the entirety of the cosmos that we can, even in principle, ever have knowledge of. It is our ultimate window on reality. Let us try to feel the scale of this. Our Laniakea supercluster, which seemed so immeasurably vast at 500 million light-years across, would be like a tiny, almost invisible speck of dust floating within a gigantic, room-sized sphere. The observable universe contains at least 200 billion galaxies, and perhaps as many as 2 trillion. These galaxies are arranged in the beautiful web-like structure of filaments and voids that we have already discussed. The entire cosmic web, with all its countless superclusters, is contained within this observable sphere. This is the final stage for our journey, the ultimate map of our cosmos. To float here, seeing the entire observable universe as a single comprehensible object, a vast, shimmering sphere of light, webbed with the delicate filaments of countless superclusters, is the ultimate cosmic perspective. It is the final, serene realization of the sheer, mind-boggling scale of our home. From our new, ultimate vantage point, looking upon the entire observable universe, we can now see our own Laniakea supercluster in its true context. It is just one thread among millions in the cosmic tapestry. As we gaze out into the 93 billion light-year sphere, we see the cosmic web stretching in every direction, filling the entire volume of space. We see other superclusters, some similar in size and shape to our own, others vastly larger and more massive. We see colossal structures like the Shapley supercluster, the most massive concentration of galaxies in our local universe, a gravitational giant toward which even our own Laniakea is slowly moving. We see the Hercules Corona Borealis Great Wall, a staggering filament of galaxies that stretches for 10 billion light-years, the largest known structure in the universe. The entire observable universe is a sea of these superclusters, an endless, three-dimensional ocean of glowing galactic filaments. The sheer number of them is beyond counting, beyond any real human comprehension. If each of the hundreds of thousands of superclusters in the observable universe is a continent, then we have spent our entire journey exploring just one small peninsula on one of those continents. The diversity and richness of this cosmic sea are immense. Each supercluster has its own unique history, its own particular arrangement of clusters and voids, its own gravitational story that has been unfolding for billions of years. To see our home in this way, as one beautiful but unremarkable structure among countless others, is the final step in our decentering. We are not at the center of the universe. Our planet is not the center of the solar system, our sun is not the center of the galaxy, and our galaxy is not the center of its supercluster. And now we see that our supercluster is not the center of the universe. There is no center. Every point is as central as any other in the vast expanding fabric of space-time. This is a deeply peaceful and democratic view of the cosmos. We are simply one part of a vast, interconnected, and beautiful whole. To float in this sea of superclusters is to finally understand the true, uniform, and majestic scale of our cosmic home. Our journey has taken us to the grandest structures in the cosmos, the superclusters that form the cosmic web. But now we will journey even further, to the very edge of what we can see, to the oldest light in the entire universe. Let us now travel outward in our imagination, past the most distant galaxies and quasars, until we reach the very boundary of our observable sphere. Here, at a distance of nearly 46 billion light-years in every direction, we are no longer looking at distinct objects. Instead, we find ourselves surrounded by a faint, uniform, and incredibly ancient glow. This is the cosmic microwave background, or CMB. Let us not think of this as a wall or a barrier, but as a warm, gentle, and all-encompassing wallpaper that lines the inside of our entire observable universe. This light is the oldest light we can possibly detect. It is the afterglow of the Big Bang itself. In the very early universe, for the first 380,000 years, the cosmos was not transparent as it is today. It was a hot, dense, and completely opaque fog of ionized plasma, a sea of protons, electrons, and photons all interacting with each other. Light could not travel freely. A photon could only travel a short distance before being scattered by a free electron. The entire universe was like the inside of a star. Then, when the universe was about 380,000 years old, it had cooled down enough for protons and electrons to combine and form the first neutral hydrogen atoms. This event is called recombination. Suddenly, the universe became transparent, the photons were set free, and they have been traveling through the expanding universe, unimpeded, ever since. The cosmic microwave background is that very first light, now stretched and cooled by 13.8 billion years of cosmic expansion. What was once the hot, visible light of a cosmic fireball has now been redshifted all the way down into the microwave part of the spectrum, with a temperature of just 2.7 degrees above absolute zero. This faint, cold, and almost perfectly uniform glow comes to us from every single direction in the sky. It is a perfect baby picture of the universe. It is not the edge of space, but the edge of time. When we look at the CMB, we are looking as far back in time as it is possible to see. We are seeing the light from the moment the universe first became transparent. This serene, ancient, and all-pervading glow is the ultimate horizon of our journey, a beautiful, peaceful, and profound wallpaper that connects the vastness of space to the very beginning of time itself. As we rest here, surrounded by the gentle, ancient glow of the cosmic microwave background, we must fully embrace one of the most profound concepts in all of science. Because of the finite speed of light, as we look deeper into space, we are also looking further and further back in time. This entire journey that we have taken, from our moon to the edge of the observable universe, has also been a journey backward through cosmic history. The light from the moon is about 1 second old. The light from our sun is 8 minutes old. The light from Proxima Centauri is over 4 years old. The light from our sister galaxy, Andromeda, is 2.5 million years old. When we look at Andromeda through a telescope, we are seeing it as it was when mammoths and saber-toothed cats roamed the Earth. The light from the galaxies in the Virgo cluster is over 50 million years old, arriving at our eyes from a time when the dinosaurs had recently gone extinct and mammals were beginning to rise. As we look at the most distant galaxies in the cosmic web, we are seeing them as they were billions of years ago, when they were young and newly formed. We see them in their infancy, chaotic and full of the brilliant blue light of rapid star formation. We are not just seeing a static snapshot of the universe as it is today. We are seeing a layered, historical record. The further out we look, the younger the universe we see. And finally, we reach the cosmic microwave background. This is the oldest light of all, 13.8 billion years old. It is a direct photograph of the universe when it was just a baby, a mere 380,000 years old. It is the ultimate historical document. This connection between space and time is a deep and beautiful one. It means that the universe allows us to be cosmic archaeologists. We can study the history of the cosmos not by digging in the ground, but simply by looking up at the sky with more and more powerful telescopes. Our entire journey through space has been a serene, backward drift through the eons. The vastness of the universe is not just a spatial concept. It is a temporal one. The two are inextricably linked in the beautiful, four-dimensional fabric of space-time. We have now reached the ultimate boundary of our vision, the soft, glowing wall of the cosmic microwave background. We have traveled to the edge of what we can see. And so, a quiet and natural question arises: what lies beyond it? What is outside our observable universe? The simple and deeply humbling answer is that we do not know, and we may never know. The light from whatever lies beyond this horizon has not yet had time to reach us. And because the expansion of the universe is accelerating, it likely never will. We are causally disconnected from anything that lies beyond our observable sphere. However, we have no reason to believe that the universe simply stops at our horizon. The cosmic principle suggests that the universe is homogeneous and isotropic on the largest scales, meaning it looks roughly the same in all directions and from all locations. If this is true, then it is reasonable to assume that the universe beyond our horizon looks much the same as the universe within it. It is likely just more of the same. More cosmic web, more superclusters, more galaxies stretching on and on. The question then becomes, for how long does it stretch? Does it go on forever? Is the universe infinite? We do not have the answer to this question. It is possible that the universe is truly, spatially infinite, a never-ending expanse of space, time, and cosmic web. It is also possible that it is finite, but simply so unimaginably vast that our tiny, 93 billion light-year observable bubble is just an infinitesimal fraction of the whole thing. In either case, the universe is almost certainly vastly larger than what we can see. This is a peaceful and humbling thought. It means that our entire, mind-bogglingly vast observable universe may be just a single grain of sand on an infinite cosmic beach. This thought gently transitions us from the realm of the known into the serene, quiet mystery of the truly unknowable. Our journey has brought us to the edge of sight and time, to the faint, ancient glow of the cosmic microwave background. Let us now linger here, at the dawn of the universe, and listen to the silent story this first light tells us. This is the echo of creation, the beginning of the cosmic story we find ourselves in. Let us focus our attention deeply on the cosmic microwave background. This is not just a uniform, faint glow. Imprinted upon it are tiny, almost imperceptible temperature fluctuations, variations of just 1 part in 100,000. These tiny hot and cold spots in the baby picture of the universe are incredibly important. They are the seeds of all the structure that we see in the cosmos today. They are the fossilized remnants of quantum fluctuations from an even earlier time, the first fraction of a second after the Big Bang, that were stretched to enormous sizes during a period of rapid cosmic inflation. Where the CMB is slightly warmer, the plasma was slightly denser. Where it is slightly cooler, it was slightly less dense. These minuscule density variations were the gravitational seeds from which everything else grew. Over the next hundreds of millions of years, gravity went to work on these tiny seeds. The slightly denser regions began to pull in more and more matter, primarily dark matter and hydrogen gas. These regions grew, becoming the first gravitational anchors of the cosmos. They were the locations where the first filaments of the cosmic web would begin to form. The slightly less dense regions, meanwhile, gave up their matter to their denser neighbors, and they began to empty out, destined to become the great cosmic voids. The entire, vast, intricate structure of the cosmic web that we explored earlier, every supercluster, every galaxy, every star, and every planet can be traced back to these tiny, random quantum seeds, whose imprint we can still see today in the faint, ancient glow of the CMB. To look at a map of the CMB is to look at the blueprint of our universe. It is the most ancient and profound archaeological artifact in existence. It tells us the age of the universe with incredible precision. It tells us the composition of the early universe, what percentage was dark matter, normal matter, and dark energy. It confirms the predictions of our cosmological models with stunning accuracy. But more than that, it is a source of serene, aesthetic beauty. To see the entire observable universe as it was in its infancy, a perfect, glowing sphere of potential, is a deeply peaceful experience. This was the moment of the universe's first sunrise, the moment it transitioned from an opaque, fiery fog into a transparent, star-filled expanse. This first glow is the beginning of all cosmic history, the quiet, humming echo of the moment of creation itself. After the universe became transparent, and the first glow of the cosmic microwave background was released, a strange and quiet period in cosmic history began. This era, which lasted for several 100 million years, is known as the Cosmic Dark Ages. The name is somewhat misleading. It was not dark because there was no light. The faint, fading glow of the CMB filled all of space, but there were no new sources of light. There were no stars. The universe was filled with a vast, uniform, and cooling mist of neutral hydrogen and helium gas, along with the invisible dark matter. It was a time of immense simplicity and quiet. Imagine the universe during this period. It was a place of profound, unbroken peace. There were no galaxies, no planets, no complex chemistry. There was only the gentle, inexorable pull of gravity, slowly and patiently at work. The tiny density fluctuations imprinted on the CMB were beginning to grow. The dark matter was clumping together, forming the first, small, invisible halos that would serve as the gravitational cradles for the first galaxies. The hydrogen and helium gas was slowly being drawn into these dark matter halos, cooling and condensing. The universe was a silent, dark, cosmic nursery, patiently waiting for its first lights to be switched on. This was a transitional period, The universe was evolving from the smooth, simple state we see in the CMB into the lumpy, structured state we see today, with its galaxies and stars. The Dark Ages were the bridge between these two epochs. It was a long, slow, and serene period of gestation. For hundreds of millions of years, the cosmos was a place of quiet anticipation, a dark stage waiting for the first actors to appear. It is a part of our universe's history that is very difficult to observe directly, as there were no light sources to see, but we can model it, and we can infer its existence. It is a peaceful and necessary interlude in the cosmic story, the deep, quiet breath the universe took before the first stars ignited and filled the cosmos with new light. For hundreds of millions of years, the universe sat in a state of quiet, dark patience. But deep within the densest, most massive dark matter halos, the hydrogen and helium gas was continuing to cool and collapse. At the very centers of these halos, the gas became so dense and so hot that a new process began. Nuclear fusion ignited. The cosmic dark ages came to a spectacular end with the birth of the very first stars. This moment, sometimes called cosmic dawn, was a pivotal turning point in the history of the universe. The long darkness was finally broken by the first points of new, brilliant stellar light. These first stars, known as population 3 stars, were very different from the stars we see today, like our Sun. They were born from the pure, pristine hydrogen and helium gas of the early universe, with almost no heavier elements. Because of this, they were able to grow to be incredibly massive, perhaps hundreds of times more massive than our Sun. And because they were so massive, they were also incredibly hot, bright, and short-lived. They blazed with a fierce blue-white light, millions of times more luminous than our Sun. They were the lonely, brilliant lighthouses in the vast, dark ocean of the early cosmos. These first stars fundamentally began to change the universe around them. Their intense ultraviolet radiation blasted out into the surrounding neutral hydrogen gas, stripping the electrons off the atoms in a process called reionization. The universe, which had become neutral and transparent at the time of the CMB, was now being turned back into an ionized plasma, but this time it was a thin, tenuous and transparent plasma, not the dense fog of the early universe. These first stars began to carve out the first bubbles of clear, ionized space in the cosmic mist. They were the pioneers that began to make the universe the transparent, star-filled place we know today. Their lives were short, but their impact was profound. They were the first generation, the ones that set the stage for everything that would follow. The first massive, brilliant stars of population 3 lived very short and very dramatic lives. Because they were so massive, they burned through their nuclear fuel at a furious rate, lasting for only a few million years before their time came to an end. And their end was as spectacular as their life. They did not fade away gently. They died in colossal supernova explosions. Explosions so powerful they would have been visible across the entire early universe. These first supernovae were the events that truly began to shape the modern cosmos. They were the first great engines of chemical creation. Inside the fiery hearts of these first stars, for the first time in the universe's history, hydrogen and helium were fused into heavier elements: carbon, oxygen, silicon, iron. When these stars exploded, they scattered these newly forged heavy elements out into the surrounding space, enriching the pristine hydrogen and helium gas of the early universe. This was a gift to the next generation. The clouds of gas from which the second generation of stars would form were now seeded with these crucial, heavy elements. The presence of these elements allowed the gas clouds to cool more efficiently, which in turn allowed them to fragment and form smaller, less massive stars, stars like our own Sun. The death of the first stars was the necessary precondition for the birth of stars that could live long enough and be stable enough to support planets and, perhaps, life. Furthermore, the supernova explosions sent powerful shockwaves out into the surrounding gas, compressing it and triggering new bursts of star formation. The remnants of these first stars, the black holes and neutron stars they left behind, also became the gravitational seeds for the first galaxies. The first, small, proto-galaxies began to form around these first stars and their remnants, in the hearts of the first dark matter halos. These first supernovae were not just destructive events, they were profoundly creative ones. They were the seeds of all the complex chemistry and all the galactic structure that we see in the universe today. The death of the first generation was the birth of the cosmos as we know it. With the death of the first stars and the seeding of the universe with heavy elements, the stage was set for the cosmos to truly blossom. Over the next few billion years, the process of cosmic evolution accelerated. The small proto-galaxies that formed around the first stars began to merge with each other, drawn together by gravity. They grew larger and larger, becoming the first true dwarf galaxies and then later, the first spiral galaxies like our own. The cosmic web, which had started as just faint, wispy filaments, became more and more pronounced as countless galaxies formed within it. The great voids continued to empty out, and the clusters of galaxies at the intersections of the filaments grew more and more massive. The universe was transformed from a simple, dark and uniform place into a rich, complex and beautiful tapestry of light and structure. A diverse ecosystem of galaxies emerged, from giant ellipticals to beautiful spirals to small, irregular dwarfs. Inside these galaxies, generation after generation of stars were born, lived and died, each one further enriching the cosmic gas with the heavy elements needed for planets and life. On one of the spiral arms of one of these galaxies, a medium-sized yellow star was born, from a cloud of gas and dust rich in the legacy of countless previous stellar generations. Around this star, a system of rocky and gaseous planets formed, and on the third of these planets, in a quiet suburban neighborhood of the galaxy, the unique and complex chemistry of life emerged. This long, slow and serene process of a universe in bloom connects the entire story of creation, from the first glow of the CMB to our own existence here, now. It is a single, unbroken and beautiful story of evolution, all guided by the simple, patient and elegant laws of physics. To see ourselves as the result of this 13.8 billion year process of cosmic blossoming is to feel a deep and profound sense of connection to the entire history of the universe. We have journeyed through the past, from the universe's fiery birth to its present glorious maturity. Now, our quiet exploration turns its gaze to the future. We will drift into the deep, silent eons to come, to contemplate the ultimate, serene fate of our universe. A story written in the language of expansion and entropy. To understand the future of the universe, we must first appreciate its most fundamental dynamic property, the fact that it is expanding. This is perhaps the most profound discovery of 20th century cosmology. The universe is not a static, unchanging stage on which cosmic events unfold. The stage itself is growing. Let us use the gentle metaphor of a canvas. The universe is like a vast, flexible canvas, and the galaxies are like small dots of paint on this canvas. The galaxies are not flying apart from each other through space. Rather, the very fabric of space, the canvas itself, is being stretched in all directions. As the canvas expands, the distance between all the dots of paint increases. This is a crucial distinction. The expansion of the universe is not an explosion that happened in the past. It is an ongoing process that is happening everywhere, right now. This expansion was first observed by astronomers in the 1920s, when they noticed that almost all distant galaxies are moving away from us. Moreover, the farther away a galaxy is, the faster it appears to be receding. This is exactly what you would expect to see in a uniformly expanding space. If you were on any one of those dots of paint on the stretching canvas, you would see all the other dots moving away from you, and the more distant dots would appear to be moving away faster. This is why we say there is no center to the universe's expansion. Every point can be considered the center. The expansion is a property of space itself. For much of the 20th century, the great question in cosmology was about the ultimate fate of this expansion. Would the collective gravity of all the matter in the universe eventually be strong enough to halt the expansion and cause everything to collapse back in on itself in a big crunch? Or would the expansion continue forever, with the galaxies drifting further and further apart? The answer to this question depends on the overall density of the universe. For a long time, the evidence was ambiguous, but in the late 1990s, a stunning and completely unexpected discovery was made. a discovery that has completely reshaped our understanding of the universe's future and introduced a new, mysterious component to our cosmic story. The expansion is not slowing down, it is accelerating. The discovery, made in 1998, that the expansion of the universe is accelerating was a true revolution in our understanding of the cosmos. It was discovered by observing very distant supernovae, which were found to be fainter, and therefore farther away, than they should have been in a universe that was decelerating or even expanding at a constant rate. This meant that the expansion of space has been speeding up over the last several billion years. This was a profound shock. Gravity, the force that we thought governed the universe on the largest scales, is an attractive force. It should be pulling things together, slowing the expansion down. The fact that the expansion is accelerating implies that there must be some other, unknown energy in the universe, a mysterious, repulsive force that is pushing space apart. This unknown energy has been given a name: dark energy. Let us frame this not as a violent, explosive force, but as a soft, gentle, and persistent cosmic sigh. Dark energy appears to be a property of space itself, a kind of intrinsic energy of the vacuum. As space expands, more space is created, and so more of this dark energy comes into existence. This creates a kind of feedback loop. The expansion creates more dark energy, which in turn causes the expansion to accelerate even more. Unlike matter and dark matter, whose gravitational influence becomes diluted as the universe expands, the effect of dark energy becomes more and more dominant over time. In the early universe, the universe was much denser, and the attractive force of gravity was the winning force, and the expansion was actually slowing down. But about 6 billion years ago, the universe had expanded and diluted enough that the gentle, persistent push of dark energy finally overtook the pull of gravity, and the era of accelerated expansion that we are now in began. We do not know what dark energy is. It is perhaps the single greatest mystery in all of science. It makes up about 70% of the total energy density of the universe, yet we have no fundamental understanding of its nature. But we can observe its effect, this quiet, irresistible, and ever-increasing expansion of the canvas of space-time. This gentle push is the force that will dictate the ultimate fate of our universe, a fate of increasing isolation, cold and quiet. With the understanding that our universe is dominated by dark energy, which is causing its expansion to accelerate, we can now peacefully explore its most likely, ultimate fate. This scenario is sometimes called the heat death, though a more serene name might be the Big Freeze or the Great Quiet. It is a future that unfolds over truly unimaginable timescales, trillions upon trillions of years, so let us drift through it slowly and gently. As the accelerated expansion continues, the galaxies that are not gravitationally bound to us in our local group will be pushed away from us faster and faster. Eventually, they will be receding from us faster than the speed of light. This does not violate the laws of physics, as it is space itself that is expanding. The light from these galaxies will no longer be able to reach us. One by one, the distant galaxies will disappear from our view, their light redshifted into oblivion. In about 100 billion years, the night sky will look very different. The only galaxies we will be able to see will be the members of our own local group, which by then will have merged into a single giant elliptical galaxy, Milky Way. All other galaxies will have crossed our cosmic horizon and disappeared from view forever. Our universe will appear to be a single, lonely island universe in an endless, empty void. All evidence of the Big Bang and the larger cosmic web will have been erased from our sky. Future astronomers in this lonely galaxy would have no way of knowing that other galaxies had ever existed. The universe will continue to expand, and this single, merged galaxy will continue to age. The process of star formation will slow down and eventually stop altogether as the last of the interstellar gas is used up. The era of bright, shining stars, the stelliferous era that we now live in, will come to an end. The last, long-lived red dwarf stars, which can burn for trillions of years, will eventually flicker and die, one by one. The universe will become a much darker and quieter place, populated only by the cooling, dead remnants of stars, white dwarfs, neutron stars, and black holes. This is the beginning of the great, quiet, and peaceful end, a slow, gentle fading of the cosmic light. We now journey even further into the deep, dark future of our universe, into an era known as the degenerate era. The timescales here become so vast that they defy any intuitive grasp. We are now trillions upon trillions of years in the future. All the stars have burned out. The universe is a cold, dark, and profoundly empty place. The only objects left are the stellar remnants, the degenerate objects. There are the white dwarfs, the dense crystalline cores of stars like our sun, slowly cooling from a brilliant white to a dull red, and finally to a cold, black lump of carbon and oxygen, a black dwarf. There are the neutron stars, the even denser remnants of more massive stars, also slowly radiating away their heat. And there are the black holes, of both the stellar mass and supermassive variety. The planets that once orbited these long-dead stars will either have been consumed in their stars' death throes, or will be continuing their long, cold, dark orbits around their stellar ghosts. For an almost unimaginably long time, this will be the state of the universe. The galaxies themselves will begin to fall apart. Over trillions of years, the orbits of the black dwarfs and neutron stars within the great, merged galaxy of Milky Way will slowly decay due to gravitational radiation and close encounters. Many of them will be ejected from the galaxy, sent out to drift alone in the intergalactic void. The rest will slowly spiral into the central supermassive black hole. The universe will become even emptier and quieter. But even these degenerate objects are not eternal. Over even more mind-bogglingly long timescales, quantum mechanics predicts that even stable matter will eventually decay. Protons themselves may be unstable, with a half-life of perhaps 10 to the power of 36 years. If this is true, then all the black dwarfs and neutron stars will slowly, atom by atom, evaporate into a sea of low-energy particles and radiation. The only things left will be the black holes, and even they are not forever. Due to a process called Hawking radiation, black holes themselves will slowly, incredibly slowly, evaporate, losing mass over eons. A stellar mass black hole might take 10 to the power of 67 years to evaporate. The supermassive black holes at the centers of galaxies could take 10 to the power of 100 years. The very last, dying embers of light in the universe will be the faint whisper of Hawking radiation from the last, evaporating black hole. After the last black hole has finally evaporated, after the last proton has decayed, the universe will enter its final ultimate state. This is the dark era. The universe will be a cold, dark, and almost perfectly empty place, filled only with a dilute, cold sea of photons, neutrinos, and other elementary particles, all drifting aimlessly through a vast and ever-expanding space. The temperature will be just a tiny fraction of a degree above absolute zero, and it will continue to drop, asymptotically approaching zero but never quite reaching it. There will be no more structure, no more change, no more complexity. All the grand, beautiful structures we have explored on our journey, the planets, the stars, the galaxies, the superclusters, will be gone forever. Their matter and energy dissipated into a thin, uniform, and featureless soup. This is the state of maximum entropy, the state of ultimate thermodynamic equilibrium. It is the heat death of the universe. But let us not see this as a sad or tragic end. Let us see it as a state of ultimate peace and calm. It is a universe that has finally come to rest. The long, complex, and beautiful story of cosmic evolution will be over. The endless, gentle exhale of dark energy will have resulted in a universe of profound and unending serenity. There will be no more events, no more time in any meaningful sense. There will be only a vast, cold, and silent expanse in a state of perfect, eternal peace. This is the quiet, final whisper of our cosmos, a gentle and serene fading into an eternity of calm. Before we leave this long and quiet timeline of the universe's future, let us pause and reflect on the story as a whole. From the first brilliant flash of the Big Bang, through the long, quiet darkness of the cosmic dark ages, to the ignition of the first stars and the blossoming of a universe of galaxies, every step has been part of a single, grand, and unfolding narrative. We, on our small blue planet, are a part of this story. We are not separate from it. We are a product of it. The very atoms in our bodies were forged in the hearts of stars that lived and died billions of years ago. The light that allows us to see and the warmth that allows us to live all come from our own particular star. The galaxy we inhabit is our home, and the supercluster is our home continent. We are, in a very real and profound sense, the universe's way of becoming aware of itself. Our brief, fleeting moments of consciousness are the moments when the cosmos gets to look back and wonder at its own beauty and immensity. The story of the universe is written in light, from the first ancient glow of the CMB to the last fading whisper of a dying star. And our own lives, our own stories, are a tiny but beautiful sentence in that grand cosmic book. The knowledge that the story will eventually have an end, a long, slow fading into a peaceful quiet, does not diminish the beauty of the story itself. A beautiful piece of music is not made less beautiful by the fact that it eventually ends in a final quiet chord. This cosmic perspective allows us to see our own lives, and all of human history, as a precious and fleeting moment of warmth and complexity in a universe that is, for the most part, cold, empty, and simple. It gives us a sense of deep connection to everything that has come before us, and a sense of serene acceptance of what will eventually come to be. We are a part of this grand, unfolding story, and that is a thing of profound and peaceful wonder. Our awareness is a small, warm candle in the vast, deep, and beautiful cosmic night. Our journey has taken us to the beginning and the end of our own universe's story, but a quiet, gentle question remains. Is our universe the only one? Let us now drift beyond the edge of our own cosmic story and into the serene, mind-expanding possibility of a multiverse, a garden of other cosmic worlds. We have already contemplated what might lie beyond the edge of our observable universe. Likely, just more of the same, stretching on for an unknown, perhaps infinite, distance. This is the simplest and most direct interpretation of a multiverse, a collection of different observable bubbles within a single, larger universe. But some theories in physics and cosmology suggest an even grander and more profound possibility. They suggest that our entire universe, even the infinite expanse that may lie beyond our horizon, might be just one single, isolated entity in a much larger collection of other, completely separate universes. This is the multiverse hypothesis. It is a concept that exists at the very edge of scientific inquiry, a beautiful and speculative idea that emerges from some of our deepest theories about the nature of reality. Let us approach this idea not as a proven fact, but as a gentle, calming meditation on possibility. The idea of other universes is not just a fanciful invention. It arises naturally from several different areas of theoretical physics. For example, some interpretations of quantum mechanics suggest that every time a quantum event has more than one possible outcome, the universe splits into multiple universes, one for each outcome. In this many worlds interpretation, there is a branching, ever-growing tree of parallel universes. Another idea comes from string theory, which suggests that our universe might be a three-dimensional brain floating in a higher dimensional space, and that there could be other parallel brains, other universes, floating just a short distance away from ours in that higher dimension. Perhaps the most compelling idea for a multiverse comes from the theory of cosmic inflation, the same theory that so beautifully explains the seeds of structure we see in the CMB. Some versions of this theory suggest that the process of inflation, the rapid expansion of the early universe, may not have stopped everywhere at the same time. It might be an eternal process, with new universes constantly and randomly budding off from the inflating background, like bubbles forming in a pot of boiling water. Each of these bubbles would be a new, self-contained universe. With its own Big Bang and its own cosmic evolution, our universe would be just one of these bubbles. This idea of a cosmos of other worlds expands our sense of wonder to its ultimate limit. To help us gently grasp the concept of the multiverse, let us use a calm and simple metaphor. Imagine a vast, unseen, and perhaps infinite ocean. This ocean represents the underlying, inflating fabric of space-time, the raw potential from which universes are born. Now, imagine that bubbles are constantly forming on the surface of this ocean. Each bubble is a new, self-contained universe. Our entire universe, everything we have explored on our journey, from our planet to the edge of our observable sphere and beyond, is contained within just one of these bubbles. This bubble is vast, perhaps infinite in size from our perspective within it, but from the perspective of the great ocean, it is just one of countless many. These bubble universes are completely causally disconnected from each other. They exist in their own separate spacetimes. We can never travel from one bubble to another, nor can we ever see them or communicate with them. They are as separate from us as two different dreams. The space between the bubbles, the ocean itself, is still in a state of rapid, eternal inflation, constantly stretching and creating more room for new bubbles to form. The multiverse in this picture is not a static collection of worlds, but a dynamic, ever-growing and eternal foam of creation. This metaphor is a peaceful one. It removes any sense of cosmic loneliness. Our universe may be an island, but it is an island in a vast, beautiful archipelago of other island universes. It also gives us a new way to think about our own Big Bang. Our Big Bang was not the beginning of everything, but simply the moment when our particular bubble nucleated out of the inflating ocean and began its own, slower, more gentle period of expansion and evolution. The multiverse as a whole may have no beginning and no end. It may be an eternal, self-perpetuating, and infinitely creative system. To float in this imaginary space, to see our own universe as a single, beautiful, shimmering bubble on this unseen ocean of potential, is to feel a sense of serene connection to a reality that is far grander and more mysterious than we can ever directly know. It is a humbling and deeply calming thought. Let us now gently explore the scientific idea that gives rise to this beautiful metaphor of bubble universes. It is a theory known as eternal inflation. It is an extension of the standard theory of cosmic inflation, which has been so successful in explaining the features of our own universe. The standard theory proposes that in the first fraction of a second after the Big Bang, the universe underwent a period of incredibly rapid, exponential expansion, stretching from a subatomic size to a macroscopic size in an instant. This theory elegantly explains why our universe is so large, so flat, and so uniform. Eternal inflation takes this one step further. It suggests that the process of inflation, once it starts, is very difficult to stop. According to this theory, the inflaton field, the hypothetical energy field that drove inflation, decays randomly and quantumly. In some regions of space, the field will decay, inflation will end, and a hot, dense Big Bang will occur, creating a universe like ours. This is a bubble of grace. But in the vast regions of space between these bubbles, the inflaton field will not decay, and inflation will continue, stretching the space between the bubbles at an exponential rate. This process is eternal because the inflating regions expand so rapidly that they will always dominate over the regions where inflation has stopped. The inflating ocean is always growing much faster than the bubbles are forming within it. This theory provides a natural and scientifically plausible mechanism for producing a multiverse. It is not just a philosophical speculation, but a direct consequence of some of our most promising, though still unproven, theories about the early universe. It suggests that the creation of universes might be a common, natural, and ongoing process. The multiverse is not something that was created once in the past. It is something that is being created right now and will continue to be created for all of eternity. This scientific grounding for the multiverse concept gives it a quiet, intellectual beauty. It is a serene and elegant idea, a picture of a cosmos that is infinitely fertile and endlessly creative. The idea of a multiverse of bubble universes, born from eternal inflation, leads to a final, profound, and mind-expanding thought. It is possible that the laws of physics are not the same in every bubble universe. When each new universe is born, when inflation ends and the Big Bang occurs, the fundamental constants of nature, things like the strength of gravity, the mass of the electron, the value of dark energy, might settle down to different, random values. In this scenario, the multiverse would not just be a collection of similar universes, it would be a cosmos of infinite variety, a grand, cosmic garden where every possible kind of universe is grown. Most of these universes would be sterile and lifeless. A universe where gravity was just a little bit stronger might have collapsed back in on itself before stars could ever form. A universe where the nuclear forces were slightly different might be incapable of forming any elements heavier than hydrogen. A universe with a much larger value for dark energy might have expanded so rapidly that no galaxies could ever form. Our universe, with its particular fine-tuned set of physical laws that allow for the existence of stars, planets, complex chemistry, and life, might be an incredibly rare and precious kind of bubble in this cosmic garden. This idea offers a potential explanation for the fine-tuning problem, the question of why our universe seems so perfectly suited for life. If there are an infinite number of universes, each with different laws, then it is not surprising that at least one of them, by pure chance, would happen to have the right conditions for us to exist. We find ourselves in this particular universe for the same reason we find ourselves on a planet with water and a stable temperature. It is the only kind of place where beings like us could evolve to ask the question in the first place. This thought fills the multiverse with a sense of boundless, peaceful wonder. It is a vision of a cosmos that is exploring every possibility, a serene and infinite garden of creation. Our gentle exploration of the multiverse has taken us to the very limits of what science can currently speculate about. We have imagined our universe as a single bubble on an unseen ocean, part of an infinite garden of cosmic possibilities. It is now time to gently pull our awareness back from this grand, speculative vision and return to the shores of our own familiar reality. The multiverse, for all its beauty and elegance, is an idea that lies beyond our ability to test or observe. It is a hypothesis, a beautiful mathematical possibility, but it is not and may never be a proven scientific fact. We can never step outside our own bubble to see the others. We are, and will likely always be, confined to our own particular island universe. And so, we must accept the multiverse as a beautiful, unknowable concept, a serene meditation on the ultimate nature of reality that lies beyond our observational shore. It is a humbling and peaceful thing to accept the limits of our own knowledge. It is okay to not have all the answers. The wonder of the cosmos is not diminished by the existence of ultimate mysteries. It is enhanced by them. The multiverse serves as a quiet, gentle reminder that reality may be far stranger, larger, and more beautiful than our limited minds can ever fully comprehend. As we turn our gaze away from the unknowable shore of other universes and back toward our own, we do so with a new sense of appreciation. Our universe, with its specific laws and its beautiful, intricate structures, is our home. Whether it is the only one or one of countless many, it is the one that we have been given to explore and to wonder at. The possibility of other universes makes our own feel even more precious, more special. Our journey into the multiverse has been a journey into the heart of scientific wonder, and now, with a sense of peaceful acceptance, we return to the familiar, starry skies of our own cosmic home. The cosmic silence amplifies the meaning of this image. It tells us that this tiny, fragile world is, as far as we know, the only place where the universe has woken up and become aware of itself. It is the only place with poetry, music, and art. It is the only place with love, compassion, and contemplation. The silence of the universe places a profound responsibility upon us. The responsibility to cherish and protect this rare and beautiful anomaly. It underscores the folly of our conflicts, the absurdity of our hatreds, and the desperate importance of our kindness to one another. The great silence is the universe's way of whispering to us, telling us that what we have here is something special, something to be treasured. Let us now shift our focus away from the absence of others and toward the beautiful, profound presence of ourselves. Instead of seeing the cosmic silence as a lack, let us see it as a canvas. The vast, quiet, and seemingly empty universe provides the perfect, dark, and silent backdrop against which the beauty and wonder of our own existence can be most clearly seen. The silence of the cosmos allows us to hear the gentle, subtle sounds of our own world with greater clarity. It allows us to appreciate the soft whisper of the wind through the trees, the gentle rhythm of the waves on the shore, the quiet hum of a sleeping city, and the soft, steady beat of our own hearts. These are the sounds of life, the sounds of a living, breathing world. And they are made all the more beautiful by the deep, unending quiet of the interstellar void. The silence of the universe allows us to appreciate the simple, profound beauty of being here, now. It invites us to turn our attention away from the grand cosmic questions for a moment and to focus on the small, quiet wonders of our own immediate experience. The feeling of warmth from the sun on our skin, the intricate crystalline structure of a snowflake, the complex, interconnected ecosystem of a simple forest floor. All of these things are part of the universe's story, and they are all happening right here, on our world. The great silence is not an emptiness that needs to be filled. It is a peaceful, meditative space that allows us to appreciate what we already have. It transforms our perspective from one of seeking and questioning to one of simple, quiet being. We do not need to find our meaning in the stars. We can find it right here, in our connection to our planet and to each other. The universe has given us this one beautiful and vibrant world, and that is more than enough. The silence is not a sign that we are alone. It is a sign that we are home. It is an invitation to find peace, wonder, and meaning not in what might be out there, but in the simple, profound, and beautiful reality of what is right here. As our contemplation of the great silence comes to a close, let us form a final, serene image in our minds. Let us picture our planet, Earth, as a small, warm, and vibrant island of sound, floating in a vast, cold, and unending sea of quiet. Out there, in the interstellar and intergalactic void, the silence is absolute, a perfect and unchanging stillness that has reigned for billions of years. But here, on our island, there is sound. There is the sound of life. There is the rustle of leaves, the call of birds, the hum of insects, the crash of waves, the rumble of thunder. And there is the sound of humanity, the gentle murmur of conversation, the soaring beauty of music, the laughter of children. These sounds are the antithesis of the cosmic silence. They are the sounds of complexity, of change, of life, of consciousness. They are a small, local, and perhaps unique rebellion against the universe's overwhelming tendency towards silence and simplicity. To be on this island of sound is a precious and beautiful thing. It is to be part of something special, something rare. As we prepare for the final stages of our journey homeward, let this contrast settle deep into our awareness. The deep, peaceful quiet of the cosmos is the backdrop, the context, the sea. And our world, with all its gentle, living sounds, is the island, the home, the sanctuary. This contrast does not create a sense of fear or isolation, but a sense of profound comfort and gratitude. We are on the island of sound, and it is a good and beautiful place to be. The silence of the universe is not our enemy. It is the peaceful ocean that surrounds our home and makes its gentle sounds all the more sweet. Our journey through the cosmos has given us a profound sense of perspective, of our place in the grand, silent universe. Now, as we continue our drift homeward, we turn to a final, deep, and beautifully personal connection to the stars. We will discover that the cosmos is not just something that is out there, it is also deep within us. Let us now contemplate a simple, yet deeply profound scientific fact. Every single heavy atom in your body, the carbon that forms the backbone of your DNA, the calcium in your bones, the iron in your blood that carries oxygen was created in the heart of a star that lived and died long before our sun was ever born. You are, in the most literal and beautiful sense, made of stardust. When the universe began, in the Big Bang, the only elements that were created were the very simplest ones: hydrogen, helium, and a tiny amount of lithium. These are the light gases that formed the first stars. But our bodies, our planet, and everything we see around us are made of much more complex, heavier elements. Where did they come from? They were forged in the fiery, high-pressure cores of massive stars. Inside a star, the process of nuclear fusion is constantly at work, turning lighter elements into heavier ones. In a star like our Sun, hydrogen is fused into helium. But in stars that are much more massive than our Sun, the process continues. When they run out of hydrogen in their core, they begin to fuse helium into carbon. Then, in successive stages, they fuse carbon into neon, neon into oxygen, oxygen into silicon, and finally, silicon into iron. The core of a massive star just before it dies is like a cosmic onion, with layers of different elements, with the heaviest, iron, at its very center. Iron is the final ash of normal stellar fusion. It takes more energy to fuse iron than is released, so the process stops there. But the universe needs even heavier elements, like gold, silver, and uranium. These are created in the final cataclysmic moments of a star's life, in the incredible violence and energy of a supernova explosion, or in the even more exotic collision of two neutron stars. These events are the cosmic forges that create the full, rich periodic table of elements that makes complexity and life possible. So, when you look at your hand, you are looking at atoms that were once at the center of a dying star. The iron atom at the center of a hemoglobin molecule in your blood was created in a star that exploded billions of years ago. This is not poetry or metaphor. It is a direct, scientific, and traceable lineage. We are the children of the stars. Understanding this deep, physical connection to the stars can foster a profound and peaceful sense of belonging to the cosmos. The universe is not a cold, distant, and alien place that we are merely observing from afar. We are a part of it. We are made of it. The same laws of physics that govern the most distant galaxies are at work within our own bodies. The same elements that make up the most beautiful nebulae are the elements that make up our bones and our brains. There is no separation. This realization can dissolve any feelings of cosmic loneliness or alienation. We are not lost in the universe. We are at home in it. This sense of belonging is not a spiritual or mystical belief, but a direct consequence of our scientific understanding. It is a deep, quiet, and resonant truth. It is like the feeling of hearing a familiar piece of music, or returning to a beloved childhood home. There is a quiet hum of belonging that comes from knowing that our roots go back to the very beginning of time and stretch across the entire expanse of our galaxy. We are as much a part of the universe as a star or a galaxy is. We are a temporary but beautiful and complex arrangement of its ancient stardust. Let this feeling of serene belonging wash over you. It is a quiet, internal confirmation of our place in the grand scheme of things. It tells us that we have a right to be here, that we are a natural and beautiful expression of the universe's creative potential. The cosmos is not just our home, it is our parent, our source, our very substance. To feel this connection is to find a deep and abiding peace with our place in the vast, silent, and beautiful universe. We conclude our contemplation of our stellar origins by recognizing that this beautiful, stardust heritage is not just personal, it is universal. Every living thing on our planet shares this same ancient cosmic ancestry. The tree outside your window, the bird singing in its branches, the smallest insect, and the largest whale in the sea all are made from the same recycled atoms from long-dead stars. We are all cut from the same cosmic cloth. This shared heritage is a profound and unifying truth. It transcends all the small and superficial differences that we perceive between us. On a fundamental, atomic level, we are all family. And this connection does not stop with living things. The very ground beneath our feet, the rocks, the mountains, the water in the oceans, and the air that we breathe are all part of this same stardust legacy. The planet itself is our cosmic relative. This understanding can foster a deep sense of reverence and connection to our world and to all the life that it supports. We are not separate from our environment. We are a part of it, and it is a part of us. When we look at the natural world, we are looking at another beautiful and complex arrangement of the same stardust that makes us up. This shared heritage connects our personal sense of belonging to a universal sense of connection with everything and everyone around us. It is a deeply peaceful and compassionate worldview. It reminds us that we are all in this together, on this small blue planet, made of the same ancient and precious materials. As we now prepare for the final gentle stages of our journey homeward, let us carry this sense of shared cosmic connection with us. It is the final, beautiful realization that prepares us to return to our world not just as observers, but as fully integrated and deeply connected participants in the grand cosmic story. Our grand tour of the cosmos is nearing its end. We have traveled to the edge of space and time, and we have discovered our deep, personal connection to the stars. Now, with this new and profound perspective, it is time to begin the final, gentle journey homeward, back to the small, blue world where we began. Let us begin our return journey from the furthest point of our exploration. We are floating in the quiet, conceptual space from which we can see the entire observable universe. We look back, and we see it all laid out before us. The vast, shimmering 93 billion light-year sphere, lined with the faint, ancient glow of the cosmic microwave background. Within it, we see the intricate, glowing lacework of the cosmic web, the countless filaments of superclusters stretching across the void. It is the grandest view imaginable, a sight of serene and silent majesty. From this ultimate distance, we can just barely make out the filament that is our home, the Laniakea supercluster, a single, unremarkable thread in the universal tapestry. All of our cosmic history, all of our future destiny, is contained within that single glowing strand. This long view back is a moment of peaceful integration. We are taking all the knowledge, all the perspective that we have gained on our journey, and we are holding it all at once. We are not just seeing a collection of objects, we are seeing a single, interconnected and evolving whole. The vastness no longer feels overwhelming. It feels familiar. It feels like home. We have mapped the great continents and oceans of the cosmos, and now we are turning our ship around to sail back to our own familiar harbor. The journey back will not be a rejection of this grand scale, but a gentle zooming in, a process of finding our specific, precious place within this magnificent whole. With a final, quiet look at this ultimate cosmic vista, we now begin to drift, gently and peacefully, back toward our own small corner of the universe. Our awareness now begins its long, slow glide homeward. We drift back into the cosmic web, and the scale of our surroundings begins to resolve. The distant, faint filaments coalesce into the familiar, continent-sized structures of superclusters. We gently pass by the colossal Shapley supercluster and other distant, massive collections of galaxies, each one a universe of wonders in its own right. And then, we re-enter our own home continent, the vast, flowing river of the Laniakea supercluster. What once seemed immeasurably vast now feels like a familiar landscape. We can feel the gentle gravitational current that guides us, the shared flow of 100,000 galaxies all moving toward the great attractor. We glide through the vast outer regions of Laniakea, and we see the tributary of our own Virgo supercluster coming into view. We gently merge with its flow, leaving the larger currents of Laniakea behind. The density of galaxies around us increases as we drift through this now familiar metropolitan area of the cosmos. The great, dense knot of the Virgo cluster shines brightly at its heart, a celestial downtown that we now recognize. We feel a sense of homecoming, of returning to our local province in the cosmic kingdom. The scales that were once so mind-boggling millions and hundreds of millions of light-years now feel comprehensible, like landmarks on a well-traveled road. We are retracing our steps, but we are doing so with a new and deeper understanding. We are not just seeing a collection of galaxies, we are seeing our cosmic home, our city, our neighborhood. Each supercluster we pass is no longer just an abstract concept, but a place, a region with its own character and its own history. Our journey homeward is a process of refamiliarization, of seeing the universe not as an alien and intimidating place, but as a vast, beautiful, and ultimately knowable home. We are gliding peacefully through the grand, silent halls of our cosmic palace, making our way back to our own, quiet room. Our serene glide continues, taking us from the bustling heart of the Virgo supercluster out toward its quiet, suburban edges. The river of galaxies thins out, and the space between them grows larger and more peaceful. And then, we see it in the distance, a small, familiar and comforting sight. Our own local group. After traversing the vast continental scale of superclusters, our local archipelago of galaxies feels like a small, intimate and welcome harbor. We have returned to our local waters. The two great spiral galaxies, our own Milky Way and the majestic Andromeda, stand out like two beautiful, welcoming islands, the twin lighthouses of our home. The smaller, delicate spiral of Triangulum is there, as are the faint, ghostly smudges of the many dwarf companion galaxies that make up the rest of our local family. What once seemed like a vast and empty space between these galaxies now feels like a quiet, peaceful, and familiar bay. We have crossed the great open ocean, and we are now safely back in our home archipelago. The 2.5 million light-year journey back from Andromeda to our own galaxy feels like the final short leg of our voyage. The feeling is one of profound and gentle relief, the feeling of returning home after a long and wondrous journey. We have seen the great wonders of the cosmic world, but there is a unique and quiet comfort in returning to the familiar shores of our own galactic home. The sea of countless galaxies has now resolved into our own small, beautiful, and peacefully bound family of islands. Our journey homeward now brings us to the shores of our own particular island universe, our home galaxy, the Milky Way. As we approach it from the intergalactic void, it grows in our field of view, a magnificent, shimmering pinwheel of light against the deep, velvet blackness. We see its beautiful, graceful spiral arms, glowing with the blue light of newborn stars. We see the warm, golden light of the central bar, and the vast, spherical and ghostly halo that surrounds it all. This is our city of stars, and we are coming home. We gently drift over the top of the galactic disk, and we plunge back into its plane, into the familiar river of stars. The feeling is like descending from a high mountain back into a beloved, bustling city at night. The empty darkness of the intergalactic void is replaced by the rich, dense and beautiful tapestry of our home galaxy. The light of 100 billion suns surrounds us. We are no longer outside observers. We are participants once again, immersed in the life and light of our own cosmic metropolis. We aim for our own quiet suburban neighborhood, for the familiar, gentle current of the Orion Spur. The sense of homecoming is now deep and palpable. We are leaving the vast, impersonal scales of the universe behind and returning to a place that is ours. The Milky Way is our home in a way that no other galaxy could ever be. It is the place where our star was born, the place where our planet resides, the source of the very stardust that makes us up. To be enfolded once again in its beautiful spiral arms is to feel a deep and profound sense of safety, comfort, and belonging. We are back in the warm and gentle embrace of our own particular city of stars. Now, deep within the familiar and comforting confines of our Milky Way galaxy, we begin the final search. We are no longer navigating by the light of distant superclusters or galaxies, but by the light of individual stars. We are surrounded by hundreds of billions of them, a sea of stellar lights of every color and brightness. But we are looking for one in particular. We are looking for our own star, our sun. In this vast and crowded city, it is an anonymous and unremarkable star, a medium-sized, middle-aged yellow dwarf, just one among countless others. But to us, it is the most important star in the entire universe. It is the beacon that marks our home. We drift through the Orion Spur, past brilliant blue giants and old, dim red dwarfs. We navigate by the familiar celestial landmarks of our stellar neighborhood, the constellations that have guided travelers for all of human history. We are following the light of home, a gentle, steady and familiar glow. As we draw closer, that single stellar point of light begins to resolve. It grows brighter and warmer. It is no longer just another star. It is our sun, the heart of our own solar system. The feeling is one of profound recognition and relief. We have found our own particular street lamp in the vast cosmic city. This star is the anchor of our existence, the source of our life and warmth. Its gentle golden light is the light of home. All the wonders we have seen on our journey, from the birth of the universe to the dance of distant galaxies, are beautiful and profound. But there is a unique and powerful emotion in this final act of homing in on our own particular life-giving star. The vastness of the galaxy has now resolved into this single, singular and beloved beacon. We have followed the light, and it has led us home. We have found our sun, a single, familiar star in the vastness of the Milky Way. Now, our journey enters its final, gentle moments. We will glide peacefully into our own solar system, past the familiar worlds of our planetary family, until we arrive at our final, serene destination. We now cross the invisible boundary of the heliopause and enter our own solar system. We are back inside the protective bubble of our sun's influence. The first worlds to greet us are the distant, icy sentinels of the outer solar system. We glide past the orbit of Neptune, a deep, beautiful, and mysterious blue world, whipped by the fastest winds in the solar system. It is a cold, dark, and lonely outpost, accompanied by its strange retrograde moon, Triton. The sun from here is just a very, very bright star, its warmth barely felt. We continue our gentle drift inward, and we pass the serene, tilted form of Uranus, a pale, cyan-colored ice giant, lying on its side as it makes its long, slow orbit around the sun. It is a world of quiet, cold mystery. These two ice giants are the silent outer guardians of our solar system. They have been patrolling these cold, dark reaches for billions of years. And then, our journey brings us to the two majestic giants that rule the outer solar system. We glide past the breathtaking, ethereal beauty of Saturn, with its magnificent and intricate system of icy rings, shimmering in the distant sunlight. The sight is as familiar and as awe-inspiring as ever, a welcome and beautiful landmark on our journey home. And then, we pass the colossal, majestic form of Jupiter, the great king of the planets, with its swirling, striped clouds and its ancient, great red spot. We see its family of Galilean moons, each one a unique and fascinating world, orbiting their giant parent. These great gaseous worlds, the outer sentinels of our home, are the final, grand landmarks before we enter the inner harbor of our solar system. Having passed the majestic gas giants, our journey now takes us across the quiet, spacious river of the asteroid belt. We are entering the inner solar system, the warm, well-lit, and familiar inner harbor of our home. The sun is now no longer a distant star, but a large, warm, and brilliant disk, its presence dominating our view. The first world to greet us in the inner harbor is the rusty, red glow of Mars. The quiet desert world, with its polar ice caps and its towering, extinct volcanoes, feels like a close and familiar neighbor after our long journey through the cold outer reaches. We see the evidence of its ancient, watery past, a quiet reminder of the preciousness of the world that awaits us. We continue our drift inward, past the orbit of Mars, and we are now truly in the final stretches of our journey home. We are in the space that we share with our closest planetary neighbors. We see the brilliant, cloud-shrouded form of Venus, our sister planet, forever hiding its hot, inhospitable surface beneath its beautiful, toxic veil. And we see the tiny, swift-moving form of Mercury, making its fast, scorched journey closest to the sun. These inner worlds, once the destinations of our outward journey, are now the final markers that we are almost home. They are the familiar buoys that guide us into our final, safe port. The light from the sun is now warm, the space feels familiar, and our final, beautiful destination is now just ahead. And then, finally, we see it. Hanging in the black, silent void of space is the most beautiful object in the entire cosmos. It is a shimmering, swirling sphere of brilliant blue, dazzling white, and soft, earthy brown. It is our home. It is the Earth. After a journey of billions of light years, across the entire expanse of space and time, there is no sight more welcome, more beautiful, more profoundly moving than this. This is the pale blue dot, the beautiful living jewel of our solar system. From this distance, we can see the entire planet at once. We see the great blue expanse of the Pacific Ocean. We see the graceful, swirling patterns of the white clouds, a testament to our world's dynamic, life-giving atmosphere. We see the familiar, comforting shapes of the continents. There are no borders visible from up here, no signs of the divisions that seem so important on the surface. There is only a single, whole, and unified world. It looks incredibly fragile and delicate, a tiny, precious oasis of life suspended in the vast cosmic darkness. All of our history, all of our art, all of our science, all of our love, and all of our pain has happened on this one small world. All the wonders we have seen on our journey, from the birth of stars to the dance of galaxies, are magnificent. But it is here, on this small planet, that the universe has become conscious of itself. It is here that life exists, in all its improbable and beautiful complexity. To see it from this perspective, after all we have seen, is to feel a sense of love and protective tenderness for our world that is deeper than words. This is not just a planet, it is our home. It is the destination of our long journey, the source of our being, and the most beautiful sight in the entire known universe. Our final approach now begins. We drift closer and closer to our beautiful blue home. We glide silently past our constant, faithful companion, the moon, its familiar, cratered face a silent welcome. We cross the 238,000 miles that separate it from our world, a distance that now feels like just a small, final step. And then we begin our gentle, final descent. We encounter the very first, tenuous wisps of our planet's atmosphere. This is the thin blue veil, the fragile, gaseous shell that separates the cold, airless vacuum of space from the warm, living world below. It is the boundary between the cosmos and our home. As we sink deeper into this atmospheric ocean, we feel the first, gentle effects of friction. We are no longer in the perfect silence of space. We can now imagine the whisper of the thin air around us. We pass through the upper layers, the mesosphere and the stratosphere, where high, wispy clouds of ice crystals drift. Below us, the world grows larger and more detailed. We can now make out mountain ranges, coastlines, and the green patches of forests. We descend further into the troposphere, the realm of weather, of clouds, of life-giving rain. The air around us grows thicker and warmer. We are being enfolded in our planet's embrace. This thin veil of air is what makes everything else possible. It is our shield, protecting us from the harsh radiation of space. It is our blanket, keeping our world at a warm and stable temperature. It is the air we breathe, the substance that connects all living things in a single shared system. To pass through it is the final, symbolic act of our return. We are leaving the grand, silent and starry realm of the cosmos and returning to the small, gentle and living realm of our world. We are coming home not just to a place in space, but to a place of warmth, of air, of life. Our long, gentle descent through the atmosphere now nears its end. Our awareness glides down, through the clouds, over the continents and the oceans, over the cities and the towns, over the forests and the fields. And then, our focus narrows, our journey contracts, from the scale of a planet to the scale of a single, quiet place. Our cosmic journey, which began with a gentle drift away from our world, now finds its final, peaceful destination. Our awareness comes to rest, right here, in this room, in this quiet, safe, and comfortable space. The journey of billions of light years is over. You are no longer floating in the cold emptiness of space. You are here, resting comfortably. The vast, silent cosmos is still out there, in all its magnificent, mind-boggling scale. But you are here, safe and sound. The ground beneath you is solid and steady. The air you are breathing is calm and gentle. The silence is no longer the absolute silence of the void, but the soft, comforting quiet of your own peaceful surroundings. The entire grand story of the universe, from the first glow of creation to the slow dance of superclusters, has led to this one, simple and perfect moment. The moment of rest. The journey was not about escaping our world, but about returning to it with a new and deeper sense of wonder, perspective, and appreciation. It was about understanding that this quiet, simple moment of rest is itself a precious and beautiful part of the grand cosmic story. You are home. You are safe. You are a part of the universe. And the universe is a part of you. And now, there is nothing left to do but to let go of the journey, to let go of the story, and to drift, gently and peacefully, into the quiet, welcoming embrace of sleep. Tonight, we have journeyed from the familiar comfort of our world to the very edge of space and time. We have seen the birth of stars, the dance of galaxies, and the serene, silent fate that awaits our cosmos. We have discovered that the stardust that makes up the grandest celestial objects is the very same stardust that makes up us. In all this vastness, we have found a quiet and profound sense of home. We belong to the universe and it belongs to us. Now, the journey is over. There is nothing more to see, nothing more to learn. only the gentle, peaceful quiet that remains. It is time to let the story fade. It is time to let your mind rest. You have permission to drift off, to let go of this cosmic journey and to begin your own quiet journey into your dreams. Simply rest now, in the calm and quiet of this moment. What part of our cosmic journey tonight brought you the most peace? Feel free to share your quiet reflections in the comments when you wake. Thank you for joining me on this gentle exploration of the cosmos. If you found comfort in our journey, a like and a subscription help to support the creation of more peaceful voyages like this one. The universe is always here, waiting patiently. When you are ready for another quiet story, you can find our full collection of cosmic narrations in the playlist. For now, simply sleep.